session in the afternoon, then all new posters are already up on the boards. Are there any questions concerning today's program or any other administrative issues? Okay, seems not to be the case. Then I'm happy to welcome Professor Dr. Karen Pittel from IFO in Munich. We are going to hear a very interesting talk about dynamic modeling of primary and ancillary benefits. Welcome, the stage is yours.
Yeah, good morning, everybody. I'm looking around. Some people still look kind of tired. I'm not sure whether I will put you asleep or not. I mean, I'm not sure about the interesting part, but we'll try. Let me find my presentation first. Okay. I'm a little slow. What the hell? Nope. That's a really promising start. Yes. Okay, got it. Okay, yeah, like was already said, I'm at IFO at Munich at the Economic Research Institute and heading the Department of Energy, Climate and Resources, and so this is basically our primary interest. And I'm coming, before I went to IFO, I'm really coming from the dynamic modeling side, and now I'm heavily involved in all kinds of policy stuff that suddenly makes theory so much more attractive, because it's at least to some extent more simple, more clear. Let's say more clear, it's not more simple. Okay, so I was asked to give a presentation about the dynamic modeling of primary and ancillary benefits. I don't think I have to say anything about ancillary benefits per se, as we have heard basically a lot about it in the last 2 days. Now, dynamic modeling of primary benefits of climate policy, I think that's quite straightforward, as climate change is really one of the probably problems with the longest time horizon that we deal with in economics. And so the dynamic modeling of climate change, of climate policy, that has quite some tradition in economics, in theory, but also numerical modeling. So I think it doesn't have to really anything to be said why this is dealt with in intertemporal and dynamic models, control models. But if you look at the ancillary benefits, of course, can be a little bit of a different story, because what we heard about in the last days, or what you usually refer to as ancillary benefits in the literature, is often really flow pollution that is reduced by adopting climate policy. So reduction of particulate matter emissions, of sulfur dioxide, and so on, noise, probably the best example for flow pollution. And the modeling itself is more of a static nature, because what you do in one period not necessarily affects what's happening in another period, so you can deal with that in static models. But of course, it is effects showing up also in the dynamic model. So on the one hand, the modeling is relatively simple. Whoops. Yeah, there we are. Compared to having long-run problems. But of course, these type of short-run effects, like noise or particulate matter, can also then affect by themselves other stocks of interest. Let's say health, for example, and via health, for example, human capital formation. So usually in the very simple models that you find on climate change, climate policy in the intertemporal context, usually you just have one very simple damage equation, or one parameter that kind of goes from temperature increase directly to damages, and then there's not differentiated anymore what type of damages you actually have. It's one aggregate. It can be health problems, can be all sorts of stuff, can also be, for example, that was the slide before where I'm trying to get now. Yeah, it can be, for example, also biodiversity, which is also basically a stock problem. So you have biodiversity which is diminished by pollution, by humans grabbing more and more land, so all kinds of different things. So it's essentially also an ancillary benefit of climate policy, can also be a cost depending on how you actually conduct climate policy. But this is also usually in the very simple models that you deal with in the optimal control literature, in this dynamic literature, in the literature on dynamic models, not particularly or extra considered. Now, as soon as you want to go into more detail and try to model all these types of interactions more concretely, so the repercussions for biodiversity, the repercussions, for example, for health, the repercussions for the state of land, the state of the ocean, the state of the forests, then of course things get much more complex. And what you find more and more in the literature is kind of giving up on trying to build simple toy models that deal with that. And simple toy models, I just mean really the control optimal control problems, but rather go to the numerical models that you solve not analytically anymore, but basically simulate. So this is the class where we very fastly go into the direction of the integrated assessment models. And with respect to this more elaborate depiction of damages, that would, for example, be the fund model. Also one of the more established models that has very little detail on the economics process, hardly any, but it's very elaborate with respect to the damages that are modeled. So this is kind of where the literature is going if you want to deal with the more complex issues. Now, when you have these types of stock effects, let's label them like that, like biodiversity or like health, then you of course have an inherently dynamic problem again, because then the state of biodiversity, the state of human health also depends on what happened in the period before. So this is then also something that is right smack in the middle of the domain of dynamic modeling. Now, if you take a look at what this means for a very simple model, and I'm kind of not at the edge of research with this model. I mean, this model is an 8K simple endogenous growth model. So this was modern probably like 20 years ago. But it's kind of helpful to show the effects or the inclusions that you can make if you deal with ancillary benefits in dynamic control problems. Now, of course, you can add to this model, you can make it arbitrarily complex. You can add more elaborate endogenous growth mechanisms, technological development, you name it. But this simple model is kind of helpful in the sense that it focuses on the effects of the additional variables that you consider. I mean, this is probably one thing that most of your PhD supervisors, if you're PhD students, kind of drilled into your head. Whatever type of problem you look at, choose the model that is simplest to really depict the problem properly. We're not doing anything super fancy if it doesn't really help the problem. So this is like most simple that you can actually look at. So it's a, like I said, it's a simple AK type model. You have a welfare function where a representative household, so identical households, homogeneous agents, where a household is maximizing the present value of his utility. Then you have production, where we have a slight deviation from the usual AK function. A is simply set equal to 1. But then you have a production function where the only private factor of production entering is really capital. And then additionally, you have negative detrimental effects of pollution. And S is the global pollution stock. So the higher S, the lower actually your output that you generate. Now, the emissions process here is really simple as well. So what you have is when you use capital, then you produce pollution. So using, I mean, this is, like I said, very simplifying. So basically, could also use output. That's also sometimes done in, of course, more elaborate models. You would use directly the input of fossil energy. Here it's really simplified in that respect, and at the same time you can also use part of output to conduct abatement. So taking part of output, producing abatement goods, and reducing the effects that this pollution actually has, or reducing the pollution per se. So this would be this equation, and then you just have basically the two state variables, the two equations of motion that tell you how the capital stock develops over time and how the pollution stock develops over time. So you produce output, you use some of it for consumption purposes, you use some of it to conduct abatement, the rest is invested in the capital stock, depreciation is not considered here, simply set equal to 0, and then you know how the capital stock and basically your capacity to produce develops over time. Now, with the global pollution stock, I have assumed here kind of renewable resource form for the development of the pollution stock. So whenever you have pollution resulting from production, that adds to the stock of pollution. So, for example, the stock of CO2 in the atmosphere, and then that degenerates over time. Now, some models actually assume it's not really a renewable resource at all, but simply because it takes really a long time until it degenerates in the atmosphere. They simply set the degeneration rate equal to 0. Doesn't really make much of a difference. Okay, so that is like the probably the most simple model you can come up with, which is a dynamic control problem, an endogenous growth model, and at the same time considers global pollution. So climate change and a very abstract version of abatement, of climate policy. Okay, now if you include co-benefits, really depends on what type of co-benefit you're looking at. For example, like I said, if you are looking at the case of biodiversity, then you would add, or would have to add, a third equation of motion here, a third state variable, and I've modeled biodiversity as a non-renewable stock in the sense. Of course, there's mutations, there's new species coming up, but that just takes very long. So for all practical purposes, a non-renewable resource, and simply assuming here, very abstractive again, that the more capital you actually use in production, that means that you have more buildings, you have more covered spaces, and so biodiversity is negatively impacted by that. And the same holds with respect to pollution. So you have this negative effect on biodiversity. The dynamic control problem gets more complex because you have one more state you have to deal with. And of course, within this model, you kind of need a reason why you would actually care. And this I included in the utility function. So basically, biodiversity having through ecosystem services also a positive effect on welfare. Could also include it in production. I mean, this is basically also a modeler's choice to some extent. But if you wouldn't include it here, then you would basically lack within the model a reason to really care about biodiversity, because it wouldn't affect any of your world. I mean, this model is like a very abstract version of your world with consumption and production. And if it doesn't affect anything, then what the hell? Okay, so this is kind of sometimes weird when you look into the literature, because some of the papers, they do consider pollution, but then it doesn't do anything. And so there's like, okay, the policymaker wants to limit it, but doesn't really show up why. Okay, I think it's more convincing if you actually add it, and then you can also identify, of course, optimal policies. Otherwise, you really have to resort to the notion that the policymaker just sets an arbitrarily, at least in the model, exogenous goal. Okay, so that would be the inclusion of biodiversity. Now, if you look at, oh, wrong button. If you look at local pollution, things are a little bit easier to some extent, because you just have a flow pollution. So noise, particulate matter, it kind of enters and leaves within a very relatively short time span. So one option to actually include that would be including this local pollution as a PL, so that's local. This would be global pollution. This doesn't really change apart from the subscript. And then you have another equation that kind of shows how the capital input also leads to local pollution, and then you would have the only difference being here between the two P's. So the pollution intensity, that could be different between the two processes. Now again, we need something that is actually affected by that. In this case, also chose production. So production suffers from these local pollutions. Of course, you usually want that it still kind of pays off to invest in capital, so it might make sense to actually limit the sum of delta and gamma to something smaller than 1, so that if you add to capital, you actually have a positive effect and not a negative effect on pollution, on output. And yeah, so that is no extra state variable from a pure solution point of view, simpler. But of course, then you can enhance this entire thing again by looking, for example, at the repercussions on health. Ergo, you have another state equation, and in this case, health, I assumed simply to kind of figure into the well-being of humans. So very similar to what we had before with the biodiversity, just assuming here that you have a regenerative process, so basically that kind of people recuperate from being ill. And how fast they recuperate, the simple depiction really depends on the state of health that they're actually in. And of course, then you can add, again, health investment, spending on health, and make things a little bit more complicated. So it could be that you actually have to deal with the positive, or can reduce it when you have climate policy. It could also be the opposite. So if you have some climate policy that actually has detrimental effects on health, it can be possible as well. Then you would kind of wrap up your investment, your spending on that. Now, of course, that seems all very abstract. It also is very abstract. And especially problematic is you just add an equation and say, okay, it's getting more complicated, but you also have really hard time kind of saying ex ante what type of effect that will have on your optimal policies, especially if you deal with the interaction between different stocks, whether it's health or pollution or biodiversity. Nevertheless, this kind of questions become more and more relevant. I mean, yesterday we have seen a lot about the SDGs, the Sustainable Development Goals. And of course, some of them exactly refer to these kind of, that we here label ancillary benefits, what might be actually primary benefits in themselves. All the kind of the side effects of climate policy that I mentioned so far, you find in the Sustainable Development Goals. And it just give you one example on kind of really, for me, very exhilarating, exciting, but also very frustrating task. That is a report that we wrote in one of the councils that I'm actually on. So this is the WBGU, and probably not even half of the Germans know what that stands for. That's the Global Advisory Council, Global Change, the German Advisory Council, Global Change, I should know that, of the German government. It's an interdisciplinary group of scholars. So we have economists, we have geographers, psychologists, law people. So very mixed group of people trying to look at global problems and coming up with hopefully sensible advice to policymakers. Now, this report that I'm referring to is kind of, that's the last one we actually finished, at least the last big one. And this is exactly what we're just talking about, the interaction between different goals, between different states of the environment. So the report is basically on the repercussions of, or the interaction between, on the one hand, climate protection, on the other hand, biodiversity conservation, but also food security. So it's basically everything that is global problems, or problems on a global scale that are related to land use. So that's why we call it the land use trilemma, because there can be, of course, positive reinforcement effects between the three, but it can also go in a very wrong direction. So for example, if you look at climate protection, one heavily discussed at the moment, at least here, I'm not sure how it's everywhere else, long-term strategy to keep temperatures down or to get them down again is negative emissions. And negative emissions can mean afforestation, it can mean bioenergy and CCS, which is all land intensive. Now, if you have these really great land intensive policies that protect the climate, you might have quite some negative effects on food security, for example. Depending on how you actually conduct these policies, you might also have negative effects on biodiversity conservation. So if you use like monocultures of either bioenergy crops or also in forests, well, huge plantations of the same type of species that can have really also negative effect on biodiversity. On the other hand, if you do it right, for example, in biodiversity conservation, conducting afforestation more as a renaturalization, so growing forests again, having them diverse, etc., that can have very positive effects on biodiversity conservation. Now, this is just one example where you actually have these kind of ancillary benefits or costs from climate protection to biodiversity or from climate protection to food security, but is it really ancillary benefits? I mean, we have a biodiversity expert in our council, and he's saying it's at least as important as climate protection. So there you get kind of away from the notion that we have, usually about one being the main goal and the other just being like, oh, nice to have, but not that important. So this makes things more complicated. And also what makes things more complicated is that there's a plenitude of relations between these three. Only these three goals or spheres. If you look at ecosystem services, then of course, regulating that or finding appropriate policies, even identifying the interactions between the different spheres is much more complicated than we usually look at in our very simple models. And then suddenly you find yourself in a position being an economist and being always so smart and knowing how to do everything that suddenly you're at a loss for kind of like really smart advice, because you usually rely on having empirical evidence, having a model that actually tells you what to do, and that's not available anymore. So what we try to do in the report is actually to kind of design so-called multiple benefit strategies, so where you actually, if you improve one, you also improve the others, so you kind of get out of that trilemma. But that's all kind of qualitative only. And also, what I always have the biggest problems with, if you're an economist, you also look at trade-offs. I mean, that's basically what you do. You look at trade-offs all the time. And if you have, for example, some policy that's great for climate and just have a slightly negative effect on biodiversity, from an economist's point of view, that might actually be better than having a policy that just improves both a little. And that kind of trade-off analysis that's nice in a model is really difficult in reality. So this is kind of just showing you that the discussion about co-benefits and their assessment is really important for policy advice at the moment, but also economists very fastly get to the limits of their knowledge. So further development of models, but also finding more empirical evidence, analyzing really the interactions, also the influence of policy on it is really necessary. Okay, so much for the real world. Let's go back to modeling. Yeah, perhaps just referring to the literature, and the theoretical literature I'm meaning here. There is a large body of literature in the dynamic modeling of especially the primary benefits. So the climate policy, climate change, intertemporal control models, huge literature. I'm not even trying to actually give you all the references to it. And there's a huge body in the analytically solvable field as well as in the numerical modeling. And the numerical modeling is probably the one that's actually expanding faster at the moment. At least that's my feeling. I mean, we have seen CGE models. Yesterday, I have at least mentioned integrated assessment models, but even these type of energy models that energy system models that are used to analyze, for example, the decarbonization of the power sector, but also other sectors in the energy field, also dynamic in nature, not all of them, but some of them at least, looking at investment, but most of this literature actually does not consider ancillary benefits. As we have seen yesterday in the CGE presentation, it's usually not really included in these types of macro models. And also with respect to the IAMs, that usually holds, even if it's more of a global second stock like biodiversity, many of these ancillary benefits are very local in nature. And these models usually don't really look at the local details. At most, it's countries. Usually it's regions, so if you have Europe as a whole, then it's getting much more complicated to look actually at these local environmental benefits because you're not able to depict it in the model. Okay, yes, so now we kind of more or less elegantly came back to the theoretical literature, and I just wanted to show you one example. How this kind of modeling can look like and what kind of results you can get. So this is a very simple example. It kind of looks similar to the models that I've shown you so far. And it goes back to this kind of more traditional notion of ancillary benefits. So reducing emissions from the burning of fossil fuels with respect to CO2 usually also reduces other emissions of pollutants. Some of them are labeled here with all the sources, health effects, visibility, etc. So this is actually quite an old picture going back to the dissertation of our esteemed host, Dirk Rübbeke, so kind of borrowed it from there. But it kind of shows the type of problem that we're actually dealing with here. And it's also a joint paper of the two of us. So we have a very simple model where we try to actually take a look at what happens if you look at global and local pollution at the same time, what happens to emissions, and specifically or mostly the optimal case, capital accumulation growth, but also if you're looking at the market solution, what actually, should policies in this context be designed. And the one thing that is different also compared to, or two things are actually different with respect to the model that I've presented earlier, is that we are dealing with two countries here. So we have so-called home and so-called foreign countries, where they might actually have different strategies on what to protect. So the one is focusing on local emissions only, while the other one is looking at kind of including in their optimal policies or in their policy design, global and local pollution. And to make things a little bit more interesting, we actually have not only these emissions from local non-accumulating pollution or leading to non-accumulating pollution and the accumulating pollution, namely climate change, but also have two different types of abatement. So this is kind of going back to this observation that you often have or had, it's kind of changing, that some countries were already really concerned about climate change and tried to design policies for it, but other countries were still just focusing on the local effects of the burning of the fossil fuels. So they didn't really consider the long-term effects, but just the short-term effects. And kind of also, I mean, to me, kind of observable, also if you look at the Paris Agreement, I mean, of course, it's all about global pollution there, But some of the goals that are in the Paris Agreement do not seem to go anything beyond the kind of status quo about what you expect to happen anyway. So kind of indicating global pollution, okay, we are part of the process, but we're not really committing to reducing it by any additional action. Okay, so the model again is a simple AK-type endogenous growth model. Like I said, local and global pollution, pollution externalities on production, 2 types of abatements, and 2 identical countries. So let me show you how this model, there you can see it, looks like. So we have country H, country F, and let's look at H first. So we're producing output using capital in production, but also using output then to build up the capital stock. We use output also for consumption. From using capital, we again have the local pollution, we have global pollution, then we have one type of abatement that also is taken away from output, as we have seen before, so it limits consumption and capital accumulation, but it's only relevant with respect to the reduction of local pollution. So that could be particulate matter filters. On the other hand, we have another type of abatement that tackles the global pollution and kind of by coincidence or side effect also the local pollution. So that could be using renewable energies instead of fossil energies, for example. So really reducing greenhouse gas emissions. Now you already see that this global pollution thing is kind of at the boundary between the 2 countries, because of course if you reduce local pollution as country H, you also do a favor to country F. So you have country F basically having the same type of interactions of economy that we have just looked at. Now in equations that looks like this, so this is kind of familiar already. We have seen that. That's nothing changed in comparison to the model before, except for this one little thing, the I up here, that indicates the respective country. Then we have pollution flows and pollution abatement. Now we have these 2 types of pollution abatement. So we have AL, that's just the abatement that reduces local pollution only. And then we have ALG, and that means local and global, so it kind of reduces both at the same time. The form we have chosen here, this multiplicative form between the 2, is of course nice, because you kind of have this interaction effect between the 2, but on the other hand, it kind of limits the analysis, because you always have to do a little bit of the LG type reduction, because otherwise you would have 0 in the denominator. But if you assume that this renewable energy or climate policies are also kind of attractive just purely from a local point of view, then we're back to this actually being kind of a sensible formulation. Now we also have the global pollution stock. As before, just now we have pollution coming from both countries entering this pollution stock, and we have capital accumulation where we now have the deduction from, if you want, net production for the 2 types of abatement. So the model is very similar in most respects to the model that we have seen before. Welfare I haven't even shown here, so utility of households is simply derived from consumption. Again, no effect of pollution in there. So in that sense, also very standard. Now what we did is we looked at basically 4 types of scenarios, social planner solutions, or not social planner, just planner, because some of them are not really social planner. So 4 scenarios. On the one hand, symmetric internalization. So either both countries just care for local pollution, both care only for the damages that arise from global pollution to their own country. So they don't care about the effects in the other country. It's only their own country that matters. And in the third symmetric internalization scenario, actually they consider the global effects. And when we actually wrote the paper, we had kind of indicative evidence for that, and now we have a perfect example for the second scenario, and that's the US, I'm very sorry. a friend of mine is running the fund model, at least that's, he's one of the persons running it. And I talked to him and asked him like about adjustments to the model, adjustments to calculations, adjustments especially with respect to the social cost of carbon during the Trump administration, because suddenly the estimates for the social cost of carbon were so much lower, and it's like, what happened? And he said, of course, on one hand, the rate of time preference was used was much higher, but on the other hand, also they got, or in policy, it was decided that only local damages from climate change actually matter. So then, of course, you have much lower damage estimates than if you had the global repercussions from greenhouse gas emissions. So that's an actually case where it happened, where you have this kind of notion, we only look at what's happening at home, what you observe think you observe in many countries, but here it was very clear, at least the way he told it to me. Okay, and then we have the asymmetric internalization case, where we think, okay, one country local only, the other country actually cares about what happens globally and locally. So these are the scenarios that we're looking at. In the planner solutions, like I said, I'm not really labeling them social planner, because social planner would assume kind of a first best, and that would only be the perfect internalization case. But we don't look at instruments here. We just look at kind of, if it's a planner, what would he do if he had just that in mind, the internalization of whatever type of externality here. Okay, so let's start with the simplest case, where we only have the local internalization of externalities. And I'm looking at the balanced growth path, the BGP here. So making things much easier for myself, because everything is growing at a constant rate, and of course that kind of lots of stuff drops out. Now, if you take a look at the transition towards the balanced growth path, you actually see its saddle point stable, saddle path stable, but I'm not going into this detail here. So what you see with respect to the use of the two types of abatement is kind of logical what you see here. It's a very simple term. It just depicts the marginal productivities of the one type of abatement versus the other type of abatement. So whatever is more productive, you use more. You don't have anything that kind of alludes to the global stage, because you just don't care. Then with respect to the capital abatement ratio, things look a little bit more complicated, but not that complicated. What you actually see here is you have a positive relationship between the so-called KI, so that's the ratio between capital and abatement, so the capital abatement ratio. More capital, more pollution, more abatement, less pollution, so that's kind of the higher it is, the more pollution you have. And so a positive relationship between this variable and the pollution stock, basically also saying that if you have a higher Ka, you have a higher pollution stock. So this kind of relationship. So it's not completely solved at this stage. There's an endogenous variable still in here, the S. But you also see that you have a negative effect, or you have this term depending negatively on the alpha or the 1 minus alpha, in the sense if you have more productive abatement, you use more abatement, Ki goes down, Ka goes down. But of course, here's always this trade-off. If this becomes more productive in the sense that alpha is going down, so this term is rising, then this term is falling. So you have this trade-off between the two types of abatement that you use here. With respect to gamma, things are a little bit muddy. I mean, because gamma shows up obviously at a number of places here. So you can actually show that whether that Ka can depend positively or negatively on the gamma. The gamma is the pollution, the negative effect of pollution on output. So that was this exponent of the pollution, the local pollution in production. Now, basically, negative effects kind of clear if pollution becomes more problematic for production, so gamma goes up, then you have basically a negative effect, a negative incentive effect, because also capital productivity goes down. At the same time, if you have a larger gamma, that means, by nature of construction of the model, that your marginal product of abatement is rising. Because if you have basically more problematic pollution, then the more abatement you do, the better. or it gets, yeah, the effect that you get is larger from using abatement. And so you have those two effects, and it really depends on the other modeling parameters, which one is prevailing. Okay, then you have the pollution stock. That's relatively simple in the symmetric case because both countries are doing the same. So you have basically both two times this expression here, two times the global pollutant emission, and in the steady states where the stock of pollution is constant. And I think there was another equation. Yep, growth. Oh yeah, what economists are usually so very concerned about. So how does growth feature in here? We have, yeah, basically the typical type of Ramsey rule here, where we have, again, the effects of pollution and abatement quite apparent in this term. So the more pollution, the lower growth. The more productive abatement, the lower growth. So the more you use output for abatement and not for investment in capital stock. And this negative capital abatement ratio basically shows you that the higher the pollution stock, the lower the growth rate. So this is kind of the simplest scenario. And then, of course, if you get more complex by adding the effects of global pollution, first just domestic damages, then global damages, terms get a little bit more complicated, but perhaps I think a nice way to show the effects is actually using this type of depiction. So we have the capital abatement ratio here. We have an omega, which is then changing depending on the internalization scope. And we have one term that's not changing at all. So we have solved here in comparison to the slide before, also for the equilibrium pollution stock, so that doesn't show up here anymore, but we basically get the part that's actually constant between the different scenarios. Now this was the case that we just had, the internalization of the local externality only. And now if you have this kind of decentral or only home damages considered internalization of the global externality, actually what you get is simply an additional term here, and this additional term represents the present value of damages from having this global pollution adding to the pollution stock and then affecting output. And of course, if you invest in a unit of capital today, then you not only have more pollution today, but in all future periods. We don't have any depreciation here, so whatever you have in the capital stock will pollute in all future periods. Okay, that's why we have to consider the present value of the pollution, of course. The delta, again, the parameter for the intensity of the pollution effects on output of the global pollutant, and you see basically negative exponents. So this is, if this is higher, then we have an incentive to invest more in abatement or use more abatement and invest less in the capital stock. And here we basically have the present value of the damages that I get from investing in the capital stock. Now the 1/2 here that I kind of showed in blue is simply due to the fact that we have identical countries, so it's always kind of whatever the entire group is doing by half, you're at one country, and since only the domestic damages are considered, you just have half the effect in here. If you go to the perfect internalization, then this half drops out. So what you get is basically an additional term here and here. So this becomes larger, the capital abatement ratio goes down, so you invest more in abatement as you would have thought, and invest less in capital. What you have, this step is really clear because you have an additional term here. This is a little bit more complicated because, of course, once the 1/2 drops out, this term is larger altogether, but then you also have this endogenous variable in here, and that's the consumption capital ratio. So it basically gives an idea of how much you consume and how much you pollutingly invest. And then, of course, if you go from the partial internalization to the perfect internalization, also this ratio changes and potentially could offset what you have from going to 1/2 to from 1/2 to 1. And we can actually show that in which direction this developed depends crucially on the intertemporal elasticity of substitution, but no matter in which direction it goes, the second order effect is never dominating the first order effect. So you always, you have basically the capital abatement ratio going further and further down with the increasing scope of internalization. Now with respect to growth, kind of the same story. You again have additional terms now with respect to this psi here, where you have an additional term subtracted in the numerator and additional term added in the denominator. So basically this expression goes down. So negative effect on the growth rate from increasing increasing internalization. But on the other hand, of course, you also have an effect on the Ki here. And the Ki, like we said, goes down. So you have less and less global pollution. And you have a lower and lower capital abatement ratio. And actually turns out that this effect is dominating. So basically, when you reduce, or if you increase internalization, the positive effect via the lower global pollution stock and also the lower local pollution leads to more growth because you have a higher productivity of capital because the drag on growth through pollution is lower. So altogether, although you have this kind of going down, the effect on Ki is offsetting that. Okay, yeah, I think already said that. Short, because I'm running out of time, more or less. Some words about the asymmetric internalization. Like I said, in this case, the foreign country only cares about the local pollution, home country cares about both. And in this case, what we kind of expect is we do have a higher pollution stock than under perfect internalization. Not really surprising. You have a lower stock than if you only look at local pollution. But then you also have, compared to the case where only local internalization is conducted by both countries, you actually have a higher abatement of the local pollutant in the foreign country as well, although they don't care about the global pollution, but through the other countries conducting the environmental policy, the climate change policy, of course the S goes down comparatively, making your own production more productive, and thereby having a higher incentive to actually mitigate the effects of your local pollution. So the climate policy, basically in home country, also has a positive effect on the pollution abatement in the other country, on the local pollution abatement. Now, with respect to the other country, the country that is actually caring about the global pollution stock, what you observe is compared to a scenario where both care about the global pollution stock, you conduct less local and less global abatement. And that's basically due to the other country not carrying the pollution stock being higher, their negative productivity effects of this pollution stock also being higher compared to a situation if both are active. So basically the country that does not conduct the climate policy profits from, in comparison to if the other country did nothing with respect to the global pollution as their own local pollution goes down. With respect to country H, they basically have facing a worse situation than if both countries were conducting climate policy with respect to local and to global pollution. And I think that's exactly, yes, what is said here. Market solution, I kind of grappled with that for a while because I kind of figured, okay, we have one externality here, right? So just one market failure, one instrument. Tinbergen, very easy. Turned out, didn't work. So actually it turned out you need two instruments here, one addressing the local and one the global pollution, in order to get the relative price between the two abatement technologies, right? And also the abatement versus capital investment decision. So the relative prices of that. So you have two instruments. You have one pollution flow tax, that takes this form. So that's basically the Econ 101 or Environmental Econ 101 rule that if you have a flow tax, then the optimal tax level should be equal to the marginal externality cost, the marginal damages that is caused by that pollution. And in the case that you have flow pollution, quite easy term. If your pollution stock then looks a little bit more complicated because you have to take account of the present value of the damages that's caused in all the future periods. And so you have, of course, in both here, the delta and gamma showing up, so the pollution in productivity or disproductivity on output. You have here the additional term where the A is representing the regeneration rate of the pollution stock. So the higher that is, the less long the pollution is in the atmosphere. So the lower the present value of the damages. And here, if the C is higher, it is going up compared to the K. So if the consumption capital ratio goes up, that also means that you invest less in the capital stock. You consume more, that's gone. And the less in the capital stock basically means you have less pollution from current production going into the atmosphere. And that's also why then the present value is declining. And here also showing up basically the two again, so you need twice as high a global tax level or pollution tax, stock tax level if you have perfect internalization. Okay, almost done. So of course, like I said, that's a really, really, really simple model. And I haven't really looked in detail at this literature for a while, so there might be some of you who actually know many more papers than I do. But there's a couple out there who try to also, for example, take a look at the atmospheric implications of sulfur dioxide emissions and the sulfur dioxide emissions going down. But still, there's a lot to be done that can be added with respect to other types of ancillary benefits and other types of dynamics caused by that. But also with respect to this very simple model, there's of course a lot of simplifications that just made our life easier. We did not consider any strategic interaction in the decision on what type of pollution to actually care about, because we saw that you actually profit if the other country is doing something, you're not spending any resources on that. So there could be strategic interaction, depending of course also on the number of countries you're considering. Then we assumed simply that these countries are all the same, which is obviously not true. So that could also be interesting to take a look at that. But also then alternative policy schemes. We just looked at a carbon tax here. Of course, there's other types of policies possible. And I've just mentioned matching here because we have two matching experts in the room, at least, Wolfgang Buchholz and Dirk Rübbeke. And so I'm guessing that perhaps Wolfgang is saying a little bit more about matching also in his presentation. I'm not sure, didn't talk to him about it, but could imagine that. Now, one last word about some further food for thought. I'm not sure whether that's really food for thought, but just thinking about it during the last days again and listening to the presentations, everything, I just think we have to kind of not only consider like this choice between different climate policies and their alternative benefits that we actually saw about yesterday, and I thought that was really interesting, also with respect to justice considerations, but we should also spend more time actually thinking about ancillary costs, because that is something that is not really fitting into the narrative most of the time, that actually climate policy could have negative effects on other dimensions that we actually care about, that actually also contribute to welfare. And this should also, I think, be considered in modeling in the economic analysis more than it has been in the past. So for example, I just mentioned two things here. The one, I already talked about the afforestation to offset emissions that could reduce, depending on how it's done, biodiversity. But then also, for example, renewable energy, where you actually need other materials that you needed for conventional energy production, and how these materials are mined also, of course, is a question that determines how much additional externalities you might cause, or perhaps also how much good you might cause with respect to local income generation, etc. So, but this is something I think we should take more account of, especially going deeper and deeper into the decarbonization. I mean, the first things were kind of easy. They were relatively cheap, and you didn't have to change much in terms of your lifestyle, your production methods, just doing a little bit less of something. But then, of course, the deeper and deeper you go, the harder and harder it gets to actually get rid of those last percents of emissions. And the more and more you really have to change, not only, which is inconvenient, your consumption habits, but of course also the production technologies. And that is renewable energies is one of them, but then of course you have the entire discussion about hydrogen, about synthetic fuels, and it just goes on from there. So I think this, considering not only these direct costs and direct benefits, but also the ancillary benefits and costs, is something that we have to be more aware about. Okay, that was it. Thank you very much for listening. Are there any questions? Is anybody still awake?
Thank you for the presentation. Quite a lot of equations to digest. Yeah, so I found it very interesting, the dynamic model, but I would like to refer to the last slide, actually, to the entire model. The last slide, food for thought.
I'm sorry, it's hard to understand for me.
Last slide.
Yes. I'm sorry, no, my hearing is not that great. And let me just, how do I do this? Okay, I just have to.
Yeah, I can tell you also, so it doesn't matter. It doesn't matter, so I can tell you.
I'll just do it while you're talking.
Yeah.
Yeah. The last model, just the extensions or the food for thought, or which one?
Yeah, yeah, exactly, the first one. The renewable energy generation needs. So the recent IEA report shows like electric vehicle needs 4 times mineral resources than conventional cars. That is also that if we...
It depends on what type of resources you're talking about probably, right? Because I mean, they need less fossil energy resources, obviously.
Yeah, I'm not talking about, so you are actually, it is balanced. You are either taking oil or taking materials.
Yeah.
So it is both of them are coming from the earth. So something like this. There are many externalities. If you look at even wind turbines, solar, they needs a huge amount of materials. So definitely this belongs to these ancillary costs. Mm-hmm. So is there any model, or your model, the model you presented, can be used or can be further extended to analyze the level of sustainability? Is this really sustainable? Like up to what amount of sustainability we can digest actually because of this cost, and the main question is up to what amount of sustainability is really sustainable? Which model can we use, or can we extend some models until to explore this research question?
Yeah, I mean, basically, starting with the numerical models, I'm not aware of a model that actually takes that into account. I mean, you could do it. There's models of, for example, other types of resources. The coal market model that's global, that considers extraction costs and whatnot, gas markets. But I don't know a model like that. That would be a partial equilibrium model, obviously, that actually looks at the mining of these types of resources that you need for renewable energy production. So on that side, I don't know anything with respect to the integrated assessment models or CGE models. I'm not aware of a model that considers that as well, although, I mean, there's, you might want to take a look at the integrated assessment model, the REMIND model of the Potsdam Institute of Climate Impact Research, because they have in their model quite a detailed energy sector. And I know that they have much detail with respect to the fossil, and I think they also did studies with respect to more detail on the renewable energy production. It could be, very tentatively, that they have something in there. Now, with respect to the analytical models, you can extend them to capture that. I mean, in this case, you would need also basically the either inputs of fossil energy or renewable. So you would have, for example, a CES function that shows that choice, or however you want to model it, renewable resources in there, and then also the production process of these renewable energy investments, basically. It's not the generation per se, but it's basically setting up the installations for which you need these materials. And then you could add environmental costs to that. So that would be possible. And there is some rising interest in, especially in the context of circular economy. Because, of course, that's becoming more and more of a political topic. For example, this entire EU Green Deal. I mean, not only mitigation of emissions, but also very much about fostering, starting, incentivizing more circular economy, especially also recycling activities. And I've seen also these types of dynamic models that consider recycling, basically, as a form of circular economy.
Yeah, this circular economy things are very attractive, but the problem is we still cannot recycle wind turbine.
We cannot do what?
We cannot recycle wind turbine. Wind turbine we cannot recycle.
Oh, not yet.
So
no, I mean, that
in
is...
our energy mix, we have a huge amount of wind energy we are planning, but we still do not have technology or things like that or to recycle wind turbines. But we are still putting this in our energy mix, a huge amount of things. Yeah.
And I'm going out on a limb here, but I'm pretty sure this is becoming a huge topic in a couple of years. I mean, seems to be the stages of development of energy policy. First, you worry about how to get it out there, the new installations, and then afterwards you start worrying about recycling. And I mean, you can imagine policy frameworks where you actually incentivize that, incentivize it quite strongly. But these types of policies are not yet into place. I mean, usually it's just cheaper. I mean, that's the economist's point of view, right? Choose whatever is seemingly cheaper, if you abstract from all the externality costs. And that is still going for kind of virgin materials, not going for second-hand materials. But looking at the amount of wind power, at solar the same, that you will need if you're basing your future energy system on renewable energy and not on, I mean, nuclear is a whole different topic, then this will become a huge topic sooner or later. I mean, on the one hand, of course, all the iron, that's one thing that you have in there, or the steel, but then, of course, also more scarce minerals or other minerals that are even more detrimental to the environment if you mine them. So I'm pretty sure this will become a huge topic, but it's been ignored, more or less, until now. Yeah, same. Yeah, no,
hard to recycle.
I completely agree. I mean, there's also, especially in the
trash.
I mean, basically, so far, mostly in the environmentalist sphere, there's always the demand that you actually have rules for production that make the products re-engineerable so that you can actually recycle them more easily. I mean, with respect to the kind of big chunks of metal in there, that's one thing. But with respect to these kind of more trace amounts that you have in there, that gets really complicated. And I know that there's research on how to do that, but of course, as long as the incentives are not really in place to do it, then it's largely driven by public investment, by public funding, and not so much by private companies. Although I have the feeling that just looking at the scale of the problem, that private companies are getting aware of that and trying to get ahead of the curve and investing actually in these processes. Whether it's enough, that's a different story. But they are short-sighted in many decisions, but not in all of them. So if you can reap a profit in the future, then usually you find some investment in that.
Many policies we need, like to promote circular economy,
Yeah, I mean, yeah. I mean, you need, I mean, on the one hand, if you just resort to pricing, which is usually the go-to for an economist, I mean, pricing the externalities that you have in mining them, and that's of course difficult sometimes because it's used here, but it's mined somewhere else. So you have different institutions, different rules there. And now what we observe in policy at the moment is this, at least in Germany, and I think there's talk about it on the EU scale. We have something like that in France. It's to some extent paper tigers, and that's the supply chain laws that you actually have to, you're responsible what happens at the other end of where you get your products, your intermediate products from. But it's not really working that much so far. But I mean, pricing these externalities on the one hand, so making the raw materials more expensive, but on the other hand also pricing, for example, the waste space that you would need, regulating international trade of waste more heavily. I mean, that can also contribute quite a lot. So you're not necessarily, you can, but you don't necessarily have to specify a certain recycling rate. There's also other means that you can use, and we don't make use of these instruments very much so far. Welcome.
Okay, thank you a lot. We have time for just one last super quick question with a quick answer. Has someone? Okay.
In the back.
Thank you for the presentation. I just have a quick question regarding how you capitalize stocks like health and biodiversity, because we're working on similar models, and sometimes the highest challenge is monetizing this biodiversity, health, or welfare, equity, things like that. So I just wanted to know if you describe that in the report, or this is just like a first toy model and then there's going to be another research behind? Or thank you.
I've not decided whether there's going to be more research behind it. I mean, so far it's basically a toy model. It's not calibrated in the sense that you have one number for the value of biodiversity, which is, I agree, extremely difficult. Because many of these ecosystem services, we have extreme problems in measuring them, evaluating them, especially, I mean, on the one hand, measuring them safely in a sense, or with a low degree of uncertainty, that is problematic, but others, of course, we all know that it's really hard to monetize them anyway. And I think we'll come to that also in the discussion that follows. But so far, it's simply a toy model. But there's more research on that necessarily as well, especially if now we're going back to the policy sphere, especially if the COP, the International Climate negotiations actually come up with a flexibility scheme with respect to international carbon markets, which then also affect heavily ecosystem services, local ecosystem services. So you kind of have to keep that in mind and have to get a better handle on that as well. And therefore, you need kind of estimates.
Okay, thank you, Professor Dr. Karen Pittel, for your talk and the discussion. We are now making a cut to prepare our panel discussion, which will be hosted by panel chair Professor Dr. Michael Höck, who's a member of the Faculty of Business Administration from TU Bergakademie Freiberg. And our discussants are going to be Dr. Rita d'Oliveira Baumann, Professor Dr. Wolfgang Buchholz, and again Professor Dr. Karen Pittel.
Hätte ich die Maske jetzt aufsetzen müssen? Augenblick oder? Achso, die holen sich nochmal einen Kaffee, ne?
Ja, genau, aber ansonsten bringe ich euch sofort.
Handöffner oder was brauchen wir? Ah ja, richtig, ja.
Oder möchten Sie die Präsentation, die ich geschickt habe, im Hintergrund laufen lassen? So ein bisschen?
Die Fragen?
Ja.
Nee, machen wir lieber, falls wir davon so ein bisschen
Alles klar,
abweichen.
dann mache ich einfach zu.
Ja. Die meisten haben sich jetzt schon ihren Tee geholt. Wie bitte? All right, good morning everyone. Welcome to our panel discussion on the opportunities and challenges considering co-benefits in climate policy. You probably all know the experts here sitting on at the tables. I'm gonna introduce them anyway. So on the left-hand side, you have Professor Bittel, who's from the LMU in Munich, expert in the field of resource economy and also working at the IFO Institute. Furthermore, we have a guest from Norway, from the Norwegian University of Science and Technology, the university where all the professors drive electronic cars. At least that's the last impression I had when I came to Norway. And on the left-hand side, you see Professor Buchholz from the University of Regensburg, also a researcher at the IFO Institute. And my name is Michael Höck. I'm an operations and supply chain professor here at Freiberg, so more on the application side. Well, and let's come right to the core of this conference and to the theme of this conference is, so what are the main opportunities and challenges considering co-benefits in climate policy? And to get you a little bit out of your comfort zone, the second question is, are economists the right people or the right experts to consider gender issues, biodiversity, and social standards? Yes, then the non-economist starts.
I think that being in an economist conference or full of economists, I say, of course, economists are important, but I don't think they should be the sole ones on this debate. And I think other types of discipline and representatives are absolutely needed in these kinds of discussions. For example, ethicists, which I tried to demonstrate a little bit yesterday, also have something to say regarding these normative implications that co-benefits have and that have been, in my opinion, fairly disregarded until now, mainly due to the associated difficulties in trying to quantify these kinds of issues and the necessary work one needs to do between the theoretical part and, of course, the more practical obstacles in doing so.
There was a statement by Antonio Guterres, that's the Secretary General of the UN, and after the recent IPCC report, he said there is a situation of code red concerning climate change. That is, there is a danger of a climatic catastrophe. There have been very strong remarks by him, and these strong remarks referred to awareness of the severity of the climate change problem. But I think this awareness is undoubtedly present in many countries, also in Germany. But, and we are all economists, or most of us are economists, we know that there is a deep, deep difference between awareness of a problem of a provision of public goods. I will tell you something on that later on the one hand, and the incentives of individuals or countries on the other hand, to make partially very costly efforts that are aiming at reducing greenhouse gas emissions at the massive scale that is required to prevent ecological catastrophe. The reason for that, you all know that, is that, as I said, climate protection is a global public good. Climate change is a global public bad, and that means that there is a divergence between the individual interests, the short-sighted individual interests, and the global interests. And this, you know, will also know that, is often modeled in game theory as a prisoner's dilemma. Yeah. And the result is that the efforts that are taken by all countries remain much lower than that what would be required just by this, following this code red to which Guterres refers. Yes, and what does this mean for, what's there, yeah? For co-benefits. I would say that against this background, the background of this deep, deep problem, this social dilemma, the important role of co-benefit is that they are very, very helpful to bridge the gap, on the one hand, between collective, global interests and individual or national interests. That the reason is quite simple. The presence of co-benefits gives the countries or the individuals some motivation to voluntarily provide to the global public good. So the social dilemma is reduced, but the empirical question is, and this could also be part of our discussion, how large this impact of co-benefits, country-specific co-benefits, really is.
Okay. Unfortunately, I have to agree that economists can't do anything, everything. Anything, yes, but not everything. Although we usually think we're top of the food chain. There's a smile, so I'm guessing that this experience is shared. I mean, somebody told me it's economists are the hardest actually to work with in interdisciplinary projects because we're so convinced that we actually incorporate everything. Now, when it comes to these types of co-benefits, like gender issues, for example, but also more material things like access to water, clean water supply, etc., I do believe that there is monetarization possible in many cases. So, for example, you could calculate the value of gender equality by looking at wages, at potential future further jobs, being there higher human capital in women, for example. So you can look at all that. But of course, there's limits, and I agree to that. That's pretty clear if you look at clean water supply. So looking at the value of clean water supply, being an economist, you would go looking at what kind of illnesses are caused by that, how much do people work less, what's the statistical value of life. That, of course, then also really depends on the country you're in. And you might decide, okay, costs are, compared to the long-term climate benefits, relatively small, so what the hell with clean water? And of course, there we see the limits, the ethical limits, where economists very fast, or which economists have to acknowledge very fast. So basically, there is certain things that are, from my perspective, that cannot be subject to these kind of trade-off calculations. So clean water supply is something that is important and that has to be made sure. Gender issues go way beyond just calculating how much extra BGP we can get from it. And so, no, economists can't do all of that. I mean, they have in the model to consider certain hard boundaries, at least that's my conviction. But by providing these types of numbers, you can sometimes also point to the importance of certain problems and can convince policymakers to actually do something. Because, for example, with gender issues is kind of a soft thing until you provide numbers on how much actually everybody can profit from making women more powerful, giving them more rights. And so while this is not all, it can help in policymaking. So I think it's kind of, it's not a yes or no answer to that.
Okay, thank you very much. Let's talk about a more specific measure, this carbon border adjustment mechanism, and whether this has an impact on protecting the steel industry, for instance, in Germany. Yeah.
Yeah. You will have read it in the newspapers that just in the last few months, also in the US and also in the European Union, the CBAMs, the carbon border adjustment mechanism, that are a complement, that should be a complement to national climate policy, have been discussed very extensively, and they appear indeed as a necessary to avoid the so-called, I do not know if you have heard about this notion, to avoid carbon leakage. That means to shelter the industry at home against migration of production and jobs to other countries that have less ambitious climate goals. And there's also much discussion on that. There are many problems related with these CBAMs. So it is questioned whether they are really compatible with the rules of the World Trade Organization, WTO. And this especially holds when these CBAMs should not only be applied to imports into the EU to create a level playing field here, but if they should, what in the end would be very desirable, that they should also be applied to exports from the European Union, also from the US. And there clearly is the danger of retaliation by the outsiders that are punished or should be punished by these CBAMs. And this may, in the end, stall international trade and the efficiency advantages that are connected with it. Yeah, what is, in this context, the role of co-benefits? The answer is very simple. We look, first of all, in the countries that, or groups of countries that introduce such rules for imports or for exports. And for that, if they have a own self-interest in avoiding greenhouse gas emissions, because that improves the quality of life in these countries, then it is not so important if industry go to other countries. That's clear. They do not want to have them any longer, perhaps, in their countries. And on the other hand, what about the outsiders that are affected by these CBAMs? Okay, for these, if they have co-benefits, if they want to reduce greenhouse gas emissions in their countries, it's clear that they lose interest to attract dirty industry to these countries. But I must say, have been general arguments, but I must say that I have some doubts if I look at the situation in Germany and the situation, say in China, that this argument is of much relevance with respect to the steel industry, because the local emissions from steel production in Germany are reduced, have been reduced very much, and can be further reduced without stopping steel production in Germany. But on the other hand, China has an interest to attract these industries. They need many steel by themselves, and it is not clear how large this interest in climate protection in China really is.
Jetzt. Yeah, perhaps coming a little bit to another issue, a further issue. I mean, the CBAM, the Carbon Border Adjustment Mechanism, might help with respect to protecting the steel industry as it is now, because, of course, like Wolfgang just said, we do have carbon prices already here. We have less intensive production processes, emission-intensive processes, which might be more expensive. So having this import tax, if you want to call it, will help to some extent. I mean, at the moment, we are still in a situation, for those of you not from Europe, where the steel industry is protected as well as other energy-intensive industries, by simply not having to pay for the certificates in the emission trading that they get. So they basically get them for free, and so they don't incur this additional cost. And in the future, that's supposed to be changed, because this mechanism can't go on forever. Once you want to reduce emissions further and further, there's just not simply enough certificates to give them. So you have to change the mechanism, you go to CBAM. Now they have to pay, but everybody who comes in also has to pay. But of course, exports are not alleviated from emission pricing, so there is still an export problem. But beyond that, when we look at the new goals that the EU has for 2050, carbon neutrality, Germany has now 2045 for carbon neutrality. What that basically means is that if you invest, for example, in new steel turbines or new steel production that is emission intensive, you'll have a big problem in 2045, because these installations are just they can be used for 30, 40 years. So we're beyond the time that we actually want to be carbon neutral. So either we have trashed, or we have to trash our investment, we have stranded assets, or we switch immediately to other types of production technologies. For example, hydrogen-based. Green hydrogen, if possible, blue perhaps as an intermediate solution, so either from renewables or from fossil energies with CCS. Now the problem is that these technologies are much more expensive at the moment than what is reflected in carbon prices. So for example, the carbon price is about, at the moment, I think it's between 50 and 60. On the European scale, I have to admit, I haven't looked for 4 weeks, and it's really dynamic at the moment. And the cheapest technology that you can have with respect to hydrogen reduction seems to be about 100 euros. That's at least an assessment I've seen. I'm not sure whether that's completely realistic. And other technologies that are really based on green hydrogen, where you have additional costs, they are like 160, 170. So the CBAM won't help with respect to changing that, because it's just the incentives are not high enough, the additional costs for imports are not high enough. So you need, additionally to CBAM, in order to get rid of the CO2 emissions fast enough, you need additional instruments. And what about the co-benefits? Yeah, of course, that's difficult with respect to, on the one hand, you get the emission reduction, but on the other hand, like Wolfgang said, you want to keep the jobs. Now, these additional instruments can, for example, the carbon contracts for difference, I'm not sure whether you've heard about that, where basically the regulator guarantees to pay the difference that you have with your mitigation costs compared to the carbon price. So kind of telling you, as long as the carbon price is not high enough, we care for the difference. If the carbon price gets really high in the future, then you have to pay me back. So that's basically the carbon contracts for difference. And by doing that, you might also be able to secure the future of the steel industry and during this transformation process. And so to keep the jobs and to generate additional effects by accumulating the knowledge, being kind of at the forefront of technological development, perhaps being able to export that in the future, although we're of course not the only ones working on that. I mean, the Chinese, for example, also invest quite heavily into these production technologies. But those would be basically what's necessary. So CBAM is nice, but for the steel industry, definitely not enough. And in order to secure the co-benefits, we need also these additional instruments to actually keep the jobs in the long run, because not only the climate would suffer from having this steel production, perhaps less less emission intensive somewhere else. Okay.
Okay, thank you.
Welcome.
Ms. Baumann.
Thank you. Well, when I look at this problem, I also see a question of potential global justice, mainly associated with the phenomenon of carbon leakage. Of course, we are all aware that many of the countries that do have these dirtier means of production will have the capacity to make greener their ways of originating these products. But I would like to call attention for the ones that might not be able to do so, and the potential effects that we will have on those countries. And by doing this kind of bilateral, I would say, approaches, we might create additional injustice sources that are already there, and I think that co-benefits could be potentially a good way to mitigate such things. But I also would like to call attention for probably the necessity to increase what we call international solidarity, for example, in terms of facilitating the access to technology developed in the countries that have that already better or improved technologies to others. And this transfer, we know it's not perfect and has not been perfect and can be further ameliorated. So this is what I think when I look at these points. And I do agree with the explanations made so far. Are we sure that this way we will indeed protect the employment of the people in these industries, since they, to my understanding, decline in terms of employment quite steep. So, yeah.
All right, thank you very much. Well, let's get this one level up and discuss how you would set the priorities, for instance, between climate protection and sustainability or sustainable development goals by the United Nations. So could you suggest some kind of coordinating mechanism between the different areas?
To do so, but at least I would again like to raise some points. I think that when we look at the SDGs, we kind of intuitively understand that probably they are not of the same relevance, and not that they are not important, of course, but I again would like to call attention that some of the SDGs look at or are focused on what we call human rights. And those, I would say, deserve some extra attention if not the only ones. And we were talking about, for example, access to water. This is a basic right. So, and we should not forget that. So maybe we could start from there, again, start from there, and use this already established and a kind of global understanding of what is a value as a departing point for this kind of discussion. The same thing also, I would say, about gender issues, right? If we understand it, we are all born equal, then the gender issues also take a different point. So, yeah.
I tend to agree. I mean, I think there's a reason why the UN didn't do a ranking of the SDGs. I mean, they're all at the same level. And so choosing between them is really difficult. Of course, we know that we have limited means to achieve them all, and that we are facing trade-offs, like we said. But from the outset, saying biodiversity is less important than climate change or something like that, I mean, human rights aside, I don't think that is really appropriate for the problem. I mean, one can also just think about the planetary boundaries that have been kind of discussed for a long time now. There's not only climate change, there's also other planetary boundaries which we need to adhere to if you want to have sustainable life on this planet for a long time. So I have a problem with really setting priorities. Of course, you have to look at the trade-offs and you have to evaluate what does one policy do with respect to the other goals. Because I think that sometimes this is not taken account of enough, that you actually have interactions between the two the 17, right, goals. And so this is something that we definitely have to take account of now. Coordination, that, and you avoided that, that's mean. That is really a Pandora's box. I mean, for an economist, it's always kind of like the obvious answer is global externalities, global environmental problems, global public goods should be taken care of on a global level. So we have a global CO2 price and all that kind of stuff. And then we have local things that should be taken care of on a local basis, local pollutants, etc. But in reality, that obviously doesn't work that well all the time. I mean, you have sometimes not the willingness to do something, sometimes you don't have the institutions, sometimes you simply don't have the money. And there is where international institutions come into play, bilateral cooperation comes into play. So I don't think that we can simply step back and say every country has to take care of their own local problems, but there has to be international cooperation as well. But then if you look at the landscape of all the actors, starting from the World Bank, the international, the IMF, the OECD, the COP, the CBD, I mean, there's so many actors, and also in this council that I talked about, we always try to come up with something smart on the global level, and it's really difficult because then you tend to say you need an organization that kind of not only like the IPCC or the COP is only concerned about climate change, or at least prioritizes that very much, but you have to kind of like have a joint conference with the CBD, who's concerned about biodiversity, but then kind of organizing these processes and getting anywhere is really difficult. So coordinating that kind of process is really a problem. But it also kind of reminds me of something that I just heard in another discussion with ministries in Germany, actually. I mean, we're shortly before a German election, as most of you probably know. Some of you will hopefully vote. I can't tell you what, because I don't know either. But anyway, we talked to ministry officials, and after the elections, there has to be a revamp of energy and climate policy in Germany, because we tightened the goals, we didn't tighten the policy, so a lot has to be done. And what was stressed by basically officials from two different ministries is that the level of coordination of climate policies at the moment leaves so much to be desired, and they actually wanted to know from us, like, how do you do it in the future? Do we need an energy ministry? Do we need a climate change ministry? Or transformation ministry? And so I think this is a question that is largely, even on a national scale, unanswered. Like, how do you actually coordinate that efficiently? Because we kind of like just like, yeah, we'll think about it. We didn't know the answer either.
Okay, please.
We are looking at the Sustainable Development Goals that have been suggested by the UN. And these SDGs represent a very, some would say, too broad class of co-benefits. And also, as many are saying, sustainability has become a catch-all-can word for all that what can be considered as good, as fair, so social justice and peace. Okay. But I have thought about what may be behind this extension. My answer is simple, a little provocative, and may appear even as a little cynical. A main reason for this extension is, in my view, rent-seeking by the developing countries, trying to, that's really a little cynical, to exploit some bad conscience in the developed countries about the climate damage these countries have caused in the past. Okay, this is, I think, legitimate to follow such a strategy. And in the short run, this strategy will also be very successful in getting transfers from the rich countries, but what countries are rich today, China and so on. But in the long run, this is my fear, this strategy may, in a certain sense, backfire. That means that it will, in the long run, not be that successful as in the short run. The reason is that people in the potential donor countries may perceive these sustainable development goals and the orientation of global policy as a distraction from the central goal, climate protection, and they clearly may also perceive financial overburdening for themselves. And this may be some contradiction, that this effect is particularly likely just when climate protection as such is considered to be of outstanding importance, e.g. when climate protection, climate policy is about preventing a climate catastrophe for the entire world. While some other, there are many sustainable development goals, are only vaguely specified, which also impedes coordination when it is not clear what these goals in fact are. And, as also people may say, they are rather sad, are based on rather subjective value judgments. And they are not uniform for all. Some interpret social justice in one way and the other interpret social justice in another way. Therefore, one should say that concentration should be on climate policy as such, and this means, to use this notion again, that the Tinbergen rule is respected.
All right, so that was a rather provocative answer to this question. So it's supposed to be a discussion. Could you comment on that?
Well, there are some easy things that we could debate there, but let's talk about a little bit about responsibility, collective and personal responsibility, and the fact that behind all of these environmental problems there is a history, and the history that we live with when we are born, right? We are born in a country, we are citizens, and of course we enter this society, whatever development that may have, because of our ancestors and the type of development. What I want to say is that, of course, there is, and I do agree, the risk of, for the people that are having a very difficult times, economically, socially speaking, developing countries, to understand why they should be burdened by something that happened in the past. And they most likely don't feel that the development that their ancestors created actually turned out into something concrete enough for them in the present. So that is indeed a problem, but we must not forget collectively that if we are having this level of welfare in developing countries, some of that was acquired by a certain type of actions that meant, that created injustice somewhere else. So of course there is this balance that needs to be sometimes reminded and maintained. And again, I think the fact that we have these international mechanisms of cooperation maintains or tries to maintain that balance. And of course, we know they are not perfect, far from it, and maybe they are even getting worse. But it's also up to us to revise them and to make them better.
Yeah, please.
My argument was clearly not against responsibility. There is a responsibility just of the developed countries to combat climate change and to provide for the green technologies that are needed for that. My argument rather has been that a broad concept of responsibility will dilute that and will reduce the willingness, democratic states, of the rich countries to transfer money to other countries. So what has been a good intention might have adverse effects, and the good intentions might, considering the political process in the developed countries, not really materializing in making the world better.
Oh, it's a lot of stuff that's in this one statement. I mean, with respect to the historic responsibility really for carbon emissions, I think we do agree that much of our wealth has been built on using fossil fuels, so that's just a fact. And that doesn't really contradict the Tinbergen rule. I mean, the Tinbergen rule could be satisfied by using a global carbon emissions trading system where you just allocate the emission rights according to historic emissions, or not emissions. So basically what of the budget is left can be attributed to you. So I don't think that's a problem with respect to which rule you actually use. And then with respect to the Sustainable Development Goals being more or less a distraction from climate policy and making, I mean, that's what I understand. Perhaps you meant it differently. So kind of making use of the bad conscience of developed countries with respect to emissions for all kinds of other purposes. I don't understand the Sustainable Development Goals like that. I mean, climate is one among many, and there is a lot of different aspects that play a huge role. I mean, some of them for developing countries, but some of them also for developed countries. I mean, contrary to the Millennium Development Goals, which were really dedicated to developing countries, the Sustainable Development Goals are really for all countries. So it's not that we are saying we're great here and we don't have to care about them, but there is huge processes also looking at them in industrialized countries. So them just like being in order to assure for something, I don't agree. And I also don't agree that, for example, may it be gender rights, may it be water access, may it be other types of things that are in the Sustainable Development Goals, that there is a feeling that it's necessarily always the fault of the industrial countries that there is some action needed. I mean, for some of the stuff, sure, we have our history with respect to emissions and colonialization and stuff like that. Lots of stuff went wrong there, but that's not all of it. So wouldn't perceive it as something to make our conscience bad. I would perceive it as something kind of putting or getting our attention in a sense that it's not one-dimensional. We're not having a one-dimensional problem with development, but we have problems in a number of respects, and we should take care of not forgetting those other things. I mean, there has been economics papers also trying to kind of rank different things, and there was a number of global threats ranking from or including climate change, including the now 1,000 times mentioned biodiversity, but for example also stuff like global pandemics. I mean, Weitzman, I think it was Weitzman or Pindyck, I'm not quite sure anymore in his paper, they basically pointed to the fact that global pandemics are a potential threat. Everybody was like, yeah, I can't really imagine that being so bad. I mean, we probably would look at it differently now and would invest differently. But I wouldn't say that that is all kind of ranking second to climate change. I mean, even if we have an increase of temperatures of 3 degrees, that will have a lot of really bad consequences. But if we ignore other problems, that might have really a lot of bad consequences economy-wise as well. So ranking climate policy above all else, no, I wouldn't see it like that. That was supposed to be provocative.
You want to comment on it?
If you look at these Sustainable Development Goals, climate protection is one goal among a lot of other goals. But if we say, I'm repeating myself, that climate protection is the most important goals, that for me automatically means that the other goals lose some of their part of their importance. And the other problem is that I often have the impression that all these problems, all these items in the Sustainable Development Goals are considered to go in the same direction. But there might be trade-offs, conflicts between them, and I think one should, if one takes this goal serious, one should start to talk about these conflicts and these trade-offs between these different goals.
All right, let's talk about these conflicts and the trade-offs. This conference was mainly about the benefits, the co-benefits of climate policy. How about the co-cost or ancillary cost?
Let me give an example that is related to Corona and the vaccines, but it can also be applied to climate change. Many people that have invented these vaccines, we are all thankful for that, have become incredibly rich. And this clearly is not, does not conform to the goal of social justice interpreted in a very simple sense. And the same, I think, will hold if someone will invent improved battery technologies.
Why does it not adhere to the principle of social justice? Why does it not adhere to the principle of social justice?
Because there is a tendency then that the equality, that the distribution of income and wealth becomes more unequal. If people have got large rents for having developed a patent for new improved technologies. This is the same, you have the same discussion with the postulate to abolish the patent law for COVID-19 vaccines. This is really a deep problem. So this conflict is not only abstract, but it is real, because one say, okay, we must tolerate these large trends, because in the long run they give incentives to develop new technologies, and the other side, oh God, I mean, these large trends are not are unfair on the one hand, and also the patent law prevents the distribution of the fair distribution of the vaccines over the entire world.
Just like to add on the subject of COVID that I think there are another very striking example of this lack of solidarity when we know that many developing countries are throwing away vaccines that could be otherwise shipped to developing countries that are in need, or maybe this question about the third vaccination shot when some of us are not even having the first one. So I would find those probably even more striking as examples of social inequality. And I think, or at least when I consider this issue, I tend to go back to the problems that we had with HIV medicine and the problem with the patents and how some developing countries tried to go further and produce them. I think Brazil was one of those cases. And I believe, at least for the non-economists amongst us, I think this discussion started to slowly fade away. And now I believe it will ramp up again now with the COVID issue. At least the discussion on it, about it should probably start again, since we also know, unfortunately, with the increase of global temperatures, the probability of this type of health events is only getting higher. So maybe we should just try to address it and probably even do it in a way that is not just vaccine-oriented, but also medicine-oriented, like the cases of malaria and so on and so forth, that again fell under the radar now that we are talking so much about the present big problem of COVID-19.
As usual, as with every question here, I think I find it really difficult. I mean, with respect to the development of the COVID vaccines, of course we have, on the one hand, a couple of companies profiting hugely from it. On the other hand, if we go with the assumption that they develop the vaccine faster because they get those rents, then you also have to look at what happens to the income distribution outside of them with and without the vaccine. So having no vaccine, perhaps if development had been slower, that also hits different groups very differently. So you might actually have the kind of trade-off, having one company, couple of people gaining hugely versus the rest of the society. And I think we agree that vulnerable groups, so people either in low-income countries or also within our society, they're more prone to lose their income. So you also have, due to the pandemic, so you also have a repercussion of having the vaccine on the income distribution in the country. So I think I find it really difficult. That said, I mean, there's also this discussion about should we have patents per se? And as far as I know, the literature in economics as well, I mean, we have all those theoretical models that actually show that we need those incentives to actually get to the socially optimal rate of R&D to innovation. But on the other hand, if you look at empirical data, you don't necessarily find that so much, that more patent protection actually leads to more R&D and faster development. So I think this is a really interesting question. How far would have we gotten if we didn't have this this type of patent protection that we have, and we wouldn't have the immense rents that we have in the due to the pandemic, but also due to other, in other markets, IT, for example. I think that's the probably most striking example. But then the original question was, what was the original question?
The co-cost.
The co-cost, yeah, the co-cost. And I think that's something that, like I said it before in my presentation, that we really have to take account of. And one of the striking examples in that sense is really what you mentioned yesterday, RED+. Or RED originally, and basically this really intelligent notion of when thinking about climate policy, also thinking about forest protection, afforestation, etc., turn out that it's in many cases at the expense of local communities and local development. And so yes, you have to consider that. Otherwise, especially if you have these kind of global market forces in play without lacking local institutions, or perhaps local institutions even kind of chipping in to using these global market opportunities, you need some security measures in order to prevent these feedback effects, these co-cost, basically.
Professor Buchholz, you want to comment on co-cost?
Very short. I think I'm more getting a liberal economist. I think, yeah, not from ideological reasons, but from empirical observations. I think that, and this relates to my remarks before, that concerning this social development sustainable development goals, not enough is said to the working of the price mechanism and the working of global capitalism.
Okay. Well, let's talk about the assessment then of benefits and cost in this context. So you want to start?
Yeah, I probably answered that question already because it was at the end of my presentation, right? So yes, I do think there's limits to monetarizing everything, co-cost, co-benefits, but also I think there is value to monetizing it. So there you have both. And I think we still lack a lot of evidence with respect to some of the co-benefits, some of the co-cost. So just don't know how much actually quantitatively, but also value-wise. So I think there's a lot of research to be done. I mean, there is already a lot of research on ecosystem services, but if you kind of try to find something specific on sometimes specific regions, specific ecosystems, then you get it very, very fast to the limits. And that's just environmental, really, economics itself, not even going towards the more human rights, more human justice dimension.
Okay. Please.
In this question, as it has been posed to us, some costs of climate policy have been called ancillary. And I have some doubt if this calling them ancillary is really helpful. I think that in this context, one should always keep in mind that climate policy will unavoidably be associated not only with monetary costs, but also with external costs through environmental degradation and, for some people perhaps, reduced quality of life, which contradicts then, to come back to that, some sustainable, some SDGs. So here in Germany, wind turbines might spoil, as many are saying, the natural scenery and make life of people living in their surroundings perhaps less pleasant, okay? But clearly, many of these costs are unavoidable if climate change is such a big problem and climate policy has to be effective. But if one has as economists and politicians, guided by economic ideas, should do if one wants to make rational decisions in case of such trade-offs. It is important that the violation of these other goals and the external effects of climate policy, also as posed to us in the question resulting from lithium production for batteries in developing countries, that these trade-offs are clearly perceived and, again, a little provocative and not swept under the carpet. And to some extent, but only to some extent, monetary valuation may be helpful for that. And special example, in the case of e-mobility, there should be truthful assessment of its costs and benefits along considering the ecological footprint of the entire supply chain. Okay, and this should also be taken into account. And perhaps this would mean, coming back to the social development goals, that making production of batteries ecologically meaningful and socially acceptable over the whole world, the cost of that will become a little higher. This is no argument for saying, okay, that is all nonsense with e-mobility and these lithium-ion batteries. No, I only say that will push up the costs if these, at the moment, perhaps external costs, are taken into account in an appropriate and correct way.
Right. Please.
Well, I agreed with what you just said. Of course, quantification and monetarization helps a lot when we want to make some kind of evidence clear to others. But as a philosopher as the philosopher would say, we can quantify everything, but are we sure we really want to do that? So I think we should also pose that question. So I do have my doubts that you could or even should do that. For example, we're talking about the gender issues. There may be some kind of dimensions that even if translated in a quantitative way, they might fall short of truly transmitting what is intended or perceived as the important point or the right point to do so. Having said that, it doesn't mean that I do not support all the kinds of research efforts to try to integrate these non-monetary issues in, for example, models. In any case, I myself trying to do to some extent, but I think it's very important to make clear when we're transmitting our ideas, the limitations of our methods. And I know that researchers do so, but I also think that sometimes policymakers tend to shut when we start saying, okay, I can only say so far. So I think it's not just the problem of the ones that are building those, but also the ones that are listening to the outcomes of their models or their research. Going back to the comments made, for example, on the problem of electrical vehicles. I do think we are definitely not taking enough in consideration the implications of, for example, mining, not only from a social but also from an environmental point of view. And if otherwise we would do that, sometimes the very techno-positive perspective on these issues would be clearly affected. But in any case, I do believe that is, of course, the pathway to go, and then probably quantification, or for sure quantification, would help a lot to make clear that, of course, the electrical vehicles and the batteries are not a panacea in itself, that sometimes we are trying, or it is being tried to be presented to the public. So,
Buzzwords, you want to comment?
Yeah, yes, concerning e-mobility, one might also hold the position, but this is again a little cynical, that neglecting these external costs at the moment will be advantageous for pushing e-mobility in the market and for making these products, e-cars, cheaper for people, and so much is done for, more is done for climate protection, and this again is one of these trade-offs I have referred to before.
Okay.
Yeah, just kind of adding to what Wolfgang said about ecological footprint tracing, etc. I think this is a topic that is so far still pretty much neglected, where we could make so much progress. I mean, due to digitization, we have so much more means to actually assess or monitor, record the emissions that we have, the impacts that we have, then putting them in a global database and then using them for policy means, but we're far from that. I mean, now we have the supply chain law, like I said, that kind of makes French, German, whoever companies responsible for the effects that they cause in other countries. We have CBAM, and CBAM kind of transfers the burden of proof to the private companies. So how much emissions were emitted in producing the goods that they imported. And is that smart? I mean, that's the question. Of course, industry is complaining a lot. But on the other hand, if you think that the government should do that, how can I actually force another country to install such a system, to require their companies to do that? So I think we need a mix of actually having these kind of using market forces in order to make private companies make their other companies do something. But on the other hand, we should have much more discussion on a global level on being able to collect this data and to store this data, changing or making use of privacy laws in a way that does not compromise the privacy of companies, that does not spill company secret, but still gives us access to this data that we need in order to be able to trace the ecological footprint. Because at the moment, that all sounds great, theoretically, and I think it would do a lot, but we're far from that, not even from CO2 emissions, not even mentioning anything else.
All right, perfect. Perfect closing word, I think, for this panel discussion. Thank you very much for your time. Well, there's going to be a coffee break, as far as I know, so enjoy the coffee.
Perhaps if somebody has a question, we might just...
Yeah.
Okay.
Here we go.
You mentioned that it is not always necessary to quantify the variables or the impact on such things like gender, poverty, maybe, and etc. I just wanted to ask, but what kind of alternatives do we have? Because first of all, we should ask ourselves, why do we tend to quantify everything? Because we want to assess the impacts and effects. Right, and otherwise we just don't know, like whether it was a positive thing or negative thing. Thank you.
I think when quantification is possible, this is a very helpful tool to make decisions more rational from economic viewpoint. But it is also clear that the possibilities of quantification are limited, and that just in the context of climate change, when we talk about the discount rate, quantification also depends on very subjective value judgments. And so we could yet separately talk about the possibilities and limits to monetary valuation of effects, but there are clearly some effects that are not quantifiable. And on my last slide, perhaps I could say this again. When we look at the SDGs, item 8, decent work and economic growth, and item 9, industry, innovation, and infrastructure, and look at the climate change, problem of climate change. In this context, different innovation and growth strategies are suggested by different people. On the one hand, something like small is beautiful, which goes hand in hand with reduced possibilities and aspiration for material consumption, modesty pace, and also a radical change of lifestyles is required. This is in the energy growth strategy, but this is, for me, at the moment, no value judgment. On the other hand, there are high-tech decarbonization strategies in which, one must say, look at the US under Biden, also nuclear energy may find its place. This difference between these two strategies, I do not know how this eminent comparison between them can be solved by convincing and accurate quantification, because you have to compare quite different paths. There is a deep structural change. The structural change that is required for the economy is different in both cases. So this has also been part of the very last question. The physical consequences of these basis conceptual approaches have to be compared, and I think quantification only is partly helpful for that. This has been a little long now.
Okay. Coming just to the modeling part, I mean, the question to me sounded, how couldn't I integrate that into the models? I mean, usually we just don't care about human rights, etc. by modeling, we're just assuming that they're given, right? I mean, that this is something we don't even have to talk about. But if you are modeling, for example, more on a micro level, considering work conditions, considering access to work, considering gender issues. I mean, there's been modeling going on in all these fields. I mean, I would stand for what I said before, that we need to probably look at some limitations of the solution space. That there is just some solutions which are we have to rule out. So we might come actually to not an interior optimum, but to boundary optimum, because we just don't want to go there. I mean, in some way we include that in growth models, for example, by assuming that there's a minimum level of consumption. Below that, basically being the implication, there's no survival, or perhaps no, perhaps physical survival, but not really something that we want. So that would be one way. If you address that explicitly in the models, then set some assumptions with respect to the solution space, where you can go and where there is something that you cannot go beyond. So excluding certain groups, or having child labor or whatever. I mean, most macro models don't even go there. I mean, they're just too aggregated. But if you really model on a more micro level, meso level, yeah, you might get there. And to me, that would be something that I would say, okay, this does not need monetization anymore. This is something that in our models we should assume that that has to be there. And then, of course, that's another matter of how to get there. I mean, that's of course, but that is kind of like things first to assure for that, and then we can deal with the secondary order questions. I mean, that would be my take.
I think they just answered brilliantly. So, two things I would like to add in, just following, for example, the question of child labor. Again, we go back to the human rights, and in this case, children's rights. We demark some kind of extreme that are mainly normative and not quantifiable. Because, of course, we could, to a certain extent, please help me here, even find an example where child labor could be, I don't know, good, I hate using this word, but would it be right? So I think there are some kind of irreducible aspects that are far from being able to be quantifiable. I'm not saying that when we can, we should, is when we can, we should pose ourselves, should we? Would that kind of benefit? Are we doing this for the sake of the love of quantifying? You know what I mean? It's nothing against, it's posing ourselves this constant question, why are we doing this? Would this benefit? And to what extent this quantification might, in some way, jeopardize when the analysis is being done by being too specific in the way we do it and losing sight of the greater picture. It's the only thing I wanted to get people reflecting on.
Perhaps also child labor. I mean, this is, I put it easier than it is, of course. I mean, because you have to assure for these things. I mean, that child labor is abolished and stuff like that. And of course, there's always the chance, always an argument for having no child labor, because investing in human capital, making them go to school, having higher rewards in the future, and so on. So there's an economic argument for that. But I guess I'm too compromised by many other disciplines to really say, okay, we should rely on that. So perhaps that's also part of my answer, that I think there is certain things that are beyond economics, in my sense. I mean, that might be for a pure economist something that's just not possible, but perhaps I'm really just too compromised. That might be.
All right, so this closes the loop actually to the first question. Thank you once again. And hope you have a good day then. Okay.
Yes, thank you again. And now we can go to our coffee break, and we'll meet here again at 11:45 for our next talk.
Firmen dabei, das Ganze zu zertifizieren, damit das eben halt sustainable, nachhaltig ist. Und da stehen die genau vor dem Problem, dass wir halt so Kobaltminen im Kongo zertifizieren müssen, und die differenzieren zwischen einem akzeptablen Level von Kinderarbeit und einem nicht akzeptablen Level von Kinderarbeit. Indem die Kinder mit den Füßen zuerst, also mit den Köpfen zuerst dann die Löcher da reingestopft haben, das ist nicht akzeptabel. Und dann, sobald sie sich mal frei bewegen können, Sorry. I was just giving an example of how difficult it is. Yeah. Yeah, right.
Das ist ja perfekt. Das ist ja perfekt. Machen Sie es her?
Von der Höhe ist es in Ordnung?
Ja. Sie machen das perfekt.
Ich mache die einfach gleich schon mal rein, dann ist die
Ja,
gleich
genau.
da.
Und dann Ctrl-L.
Ja.
Müssen wir mal finden.
Da ist es.
Ja.
Ja, genau.
Super.
Perfekt. Perfekt.
like as a little, hopefully provocative little piece coming out to kind of get some discussion on it.
Yeah.
Also, it refers to the pandemic, that human rights or freedom have been infringed upon for the greater good. How do we think about that in the context of environmental problems? Like, I'm not going there. Visiting the community.
Yeah.
This is the precedent, and where do you go?
Of course, and then again, it's always the question of trying to understand and talking about the difference between freedom and rights and responsibility, because it's lovely to talk about freedom. Usually, the discussion does not accompany the question of responsibility.
Of course, yeah.
There goes together, and I'm still believing that researchers bring these things along, because it's very interesting in the discourse. Going to this,
We're just economists. We're beyond human rights.
and the level of antibodies is very low compared to an academic. Comes into the rule, oh my God, you're to start doing this and that. So, yes, it's also a question of communication that's just really important.
Yeah.
That being an economist, it really facilitates a lot entering in the debate.
Yeah, I mean, at least with respect to your thinking, it's so easy to fit everything into categories, and that is like economist. I mean, it's certainly we do consider everything, and there's many things that are kind of in the debate outside of economics, which are true inside of economics, because they are at the end economic decisions as well. So this was really simplifying what it should be. But so in that respect, economists, I think. It's always a difficulty between normative and positive. I mean, sometimes it's just we're describing what we see, and we're not saying that GDP is the max, and growth should be maximized, and profits should be the most important. We're not saying that's good. We're just saying that's the way it is. And so I think that economists are important in that sense, but they don't have any. Yes, exactly, with respect to normative issues. And sometimes we also kid ourselves and say that what we do is actually positive and is normative. But economists are difficult.
That's true.
It's never easy to go from ideas or models to rejection. Also, from the same. So yeah, I think we can relate. It was lovely discussion.
Yeah, it was great. Thank you. And also for kind of exposing yourselves.
But you look good.
I have a question I wanted to put to you. I am actually an economist, so but the thing I was
me too. I mean,
I got that
okay.
from your presentation. Sort of, you're either an economist or some other sort of like
I'm
quantitative person who's doing the same,
I'm
doing
basically a
economics.
hardcore economist coming from theory.
Okay.
And then basically did my dissertation, my habilitation on these kind of dynamic models and all theory. And then I got to EFOS, to this institute where I'm working now, and this is much more closer to policy advice and became just more and more important. And so I find myself kind of arguing very non-economic at times.
Sure.
So this is like the story behind it.
No, honestly, most of what I was really concerned about is that when we say that there are things we are not willing to do, I'm actually normatively comfortable with that, as long as that set of things is one. Because if that set of things becomes two, we can come to a point where we have made ourselves a decision when we do not make a decision. And so I'm also, I know that we have a strong.
Perfectly aware of that, and I'm also perfectly aware of that. Like this, we just set that boundary, and that is fine. Of course, that's also then at some point down to economics, whether institutions, politicians adhere to that boundary or not.
Sure.
So I mean, this is of course it's not that easy. I mean, in modeling context, it is. You just make that assumption, and then it's there. And of course, you have then the problem that you might like have trade-offs between things, of course. But if you set these hard boundaries, you kind of get rid of that to a certain extent. You might compromise something, but not beyond a certain threshold.
Yes, what I was getting to is, so I'm happy that if sort of you're a theorist and you don't want to write human rights as a line of value, that's fine with me. Right. What I'm wondering is, I mean, sort of economics doesn't have to be done with math, like, but we do have a scarce set of things we'd like to do. And do you have another proposed way that we can decide between sort of these contradicting normative claims? I mean, I could find these are real questions that if we don't answer as academics, politicians will push down to bureaucrats, and then someone will make the decision, and no one will have thought about it.
In the end, Amartya Sen was an economist as well. Sure. And he suggested a capabilities approach that we heard about yesterday.
Yeah.
It's not really, in its essence, not being mathematical in any way.
Sure.
But I think that, I mean, our responsibility or a field of expertise is necessarily limited. So some ethical judgment questions, I think others are much more capable of answering them than me.
Sure.
And so I'm happy to rely on other disciplines as well. I mean, this is the one thing. And the other thing is, I do agree we don't have to do everything mathematically. I mean, there is like these kind of heterodox approaches sometimes. They start somewhere else, but I do think that in order to make recommendations, we should, as far as possible, try to get evidence, empirical evidence, etc. So then we're back to math to some extent, although not theory, but empirics. But so I think it has to be a mix. I mean, just doing economics purely qualitatively and kind of you have to make so many calls on what affects what to which degree, and because you just can't do that without empirical evidence. And if you don't have it, then you really have to be careful to really state clearly what are pros, what are cons, and so on. They can. I mean, there's no criteria, clear criterion on which to judge. So that makes it difficult.
I actually, do you think that part of our problem is we rely too much on empirical evidence that is quantitative? Right, I could sort of read someone's ethnography, and that would be empirical evidence. Someone went, they collected data, they wrote the data down. That is, in a very real sense, you started with the theory. Like, this is not that different from what I do. There's some different methods and some different positionality questions, right? But this is empirical evidence. There is empirical evidence in the world that is not sort of written down in a data set, or in a sort of a quantitative numerical data set.
Yeah, I mean, but doesn't it usually boil down at some point to kind of measuring? I mean, even if you do these lexicographic analysis or whatever, I mean, it's usually then you use text analysis and use it as a starting point for econometrics. So in many cases, you don't have necessarily data like scale from like a ton of emission to 100 tons of emission. You have different types of input into your analysis, but
I mean, if I were to do it, yes, this is what I know.
Yeah.
But when I open, I mean, I was trained more broadly as a social scientist. If I open, sort of a book written by a historian, sometimes they use quantitative evidence, and sometimes they don't know how to add. And right, what
they call cliometrics.
Cliometrics is sort of like is kind of an econometric version of this, but also there are people who just live in archives, right? This is sort of a pile of data that someone is processing.
Yeah, but to me, it's kind of like if I see that, especially when it comes to interpretations, I find it really interesting to then kind of use empirical evidence if you have it. Usually you don't have it.
Sure.
But if there's a possibility and kind of like contrasting it to the data, I mean, that's just interesting. But I would never say that everything has to be quantitative alone. I mean, history, also the development of politics, there's much that goes beyond what we consider in economics.
Sure.
Of regimes. I mean, there's some economics to it, but it's not all. And so I think I started studying history, but then switched to economics. So I mean, the interest is there. Also philosophy and whatever. So I think it's really, really important to have this exchange between disciplines, because at some point you tend to get stuck in your mindset, and sometimes challenging that is just so helpful. We can still decide whether you think it's a good challenge or a bad challenge. But
sure. I mean, I often find that typically what we could criticize or we're unhappy about as economists is bad economics, which is
whatever
right,
that
if you do this, look, I remain agnostic to whether there is such thing as good economics, but I am convinced that kind of is wrong.
Nee, ich will noch
Nee?
nicht. Das zweite Mikro, gute Frage.
Hier sind nur diese Standmikros.
So. Vielleicht noch ein bisschen Wasser einschenken? Nö, das geht so. Vielen Dank. We'll try. Got some takeaway. wann fährst du?
7 Minuten nach 1.
Okay, also da bin
Du bist bis Viertel vor, das wird
das wird, ja, das ist, ja. Also ich fahre 13,25.
Okay, du bist ja auch schon gleich wieder.
Ja, klar. Also das hat verschiedene Gründe, aber
Ich fahre wahrscheinlich anders, ich fahre nach Dresden.
ich weiß, das hast du gestern schon gesagt, ja. Das ist übrigens so, ich meine, also jetzt mittlerweile mit der Eisenbahn von Regensburg nach Dresden, ich meine, nicht nach Freiberg, aber nach Dresden, das ist also, da kannst du einmal so mit dem Schüttelzug da fahren, über Hof und das andere Mal irgendwie so mit dem ICE über Nürnberg-Leipzig.
Ich bin jetzt auch, als ich gekommen bin, nur mit Regionalexpress.
Und das ist eben für Freiberg ein enormer Nachteil, dass man da immer ums Eck fahren muss.
Ja, wobei jetzt bin ich gekommen, bin ich quasi bis Hof im Alex und von Hof bis
Freiberg
direkt über Chemnitz, das ging, aber es ist halt kein ICE. Genau.
Aber, also ich als alter Eisenbahnexperte, die Durchschnittsgeschwindigkeit, die ist gar nicht mal schlecht.
Ja?
Von München.
Erstaunlich, ne? Weil die ja im Endeffekt doch ziemlich teuer.
Ja, genau. Die ist gar nicht so schlecht. Also die muss ja, das geht so langsam. Wenn du das mal vergleichst mit manchen ICs, ja, kaum ein Unterschied.
Aber schön, dich mal wieder zu sehen.
Ja, wir sehen uns sicher.
In Frankfurt. Ich bin auch schon in München auch.
Ja, das mache ich sicher.
Grüß mal ganz gut deine Frau.
Ja, das mache ich. Gell?
Viel Spaß beim Vortrag.
Ja,
also war echt schön mit dir. Ich habe noch nie mit dir auf dem Podium gesessen, das war cool.
Okay.
Aber es ist auch gut, wenn man auch noch ein bisschen Streiten dabei ist. Deswegen.
Ich habe von da bis so ziemlich viel Zeit genommen. Weil diese Thematik schon so innerlich angeht. Ja. Ziemlich interessant. Also ich habe so subjektiv ziemlich was gelernt. Wobei ein Argument noch für zur Stahlproduktion. Ich meine, Kosten sind das eine, die physische Verfügbarkeit.
Oh, welcome back after our coffee break. I'm afraid I have to cut short all of your conversations so that we can now continue with our schedule as planned. And after this coffee break, I now welcome Professor Dr. Wolfgang Buchholz from University of Regensburg, who will be holding a talk about including co-benefits of low-carbon policies in models of the voluntary provision of public goods. Welcome, the floor is yours.
Thank you very much. The title has changed a little. My talk will be based on a joint paper with Anja Brumme and Dirk Grübelke. Okay, and in this talk and in this paper, we consider the allocation of so-called public goods. There are two aspects. Public goods are characterized by two properties, non-excludability and non-rivalry between the consumers of the public good. That means if some amount of a public good is provided, the benefits automatically accrue to all agents involved. And basically, the climate protection can be perceived as such a public good, even at a global scale, and climate damage then is a public bad, but that is not so important for the rest of this talk. And there are, and this is the relation to the topic of this whole workshop, there are two types of public goods. The standard case presented in textbook in public economics are the pure public good. So a pure public good is a public good where the benefits, when I contribute to the public good, the benefits of my contribution flow to all agents or all countries. And this is the relation to co-benefits. There are also impure public goods, where in addition there are such co-benefits. That means that my own contribution also has a positive effect, an individual effect for myself or for that country. You will see some examples in a moment. And there's a bunch of literature on both types of public goods, and I will refer in my talk clearly to the impure public goods with these private co-benefits. And there are many examples. For example, Todd Sandler has considered military alliances or even refugee protection. What is more interesting for us now is besides climate protection, the warm glow of giving. There are the co-benefits are psychological. That has been invented, this theory, by a famous economist named James Andreoni already 30 years ago. And this is especially relevant for Andreoni. Andreoni considered this case for charitable donations that are made voluntarily without regulation, without sanctions by the state. And agents, what is meant by that? Agents won't have a clear conscience, having the feeling that they're doing the right thing, that they're fair part in providing a collective action for providing a public good. And this has also relevance for that, what is in the center of my talk, for climate protection as a global public good with an impure component. Dirk Bergakademie has already 20 years ago written a lot about that. And what are these co-benefits? Here you have already these co-benefits have already been presented to you. They are on the one hand material, physical in one sense, co-benefits, ecological co-benefits, and economical co-benefits. The main example for that, for ecological co-benefits, is the improvement of local air quality, reduce sulfur dioxide emissions or particles emissions when the burning of fossil fuels is reduced. And economic benefits may consist in getting a leading position on the world market for new green renewable energy. Okay, but there are also, and this is related to this warm glow of giving effect, there are also psychological benefits that in the case of climate protection are of a quite specific kind. That means that the protection of the natural environment and the well-being of the future generations is considered as a very, very fundamental moral obligation. And when I fulfill this obligation, I'm feeling better, and I have a better conscience with that, and this motivates me, in addition, to do something for the global public good, climate protection. And empirically, this materializes in the many NGOs and all, like Friday for Future, that are motivated by such a warm glow of giving. And also climate protection has, in Germany and many other countries, become part of the programs of political parties. You know all that. Yeah, and For both scenarios, warm glow of giving, climate protection, and the combination of all that, provision of the impure public good is done voluntarily for donations in the case of warm glow of giving, individual donations to Caritas and so on, okay? In the scenario with climate protection, the agents are considered as the different countries in the world or groups of countries, and there is no world government that can coordinate the actions of these countries. So in the end, we have also in the case of climate protection, the situation of a non-cooperative, voluntary, private contribution of this public good. So this is a relatively appropriate description of the situation we are confronted with in the case of climate protection. Yeah, and the other thing is, there is also a private utility of contributing to the public good. So there is a difference, divergence, between the case of pure public good and the case of impure public good. And this is a rather theoretical talk. The theory of private, non-cooperative provision of public goods has been developed in the 1980s by Korns and Sandler and Bergstrom and Bloom and Varian for the case of pure public goods. But also some literature, I also quoted here something, has developed that has considered private provision of impure public goods. But if you look into the literature, I cannot present clearly this in detail, you will see that between these two types of public goods, the literature on private provision is very, very different. And the analysis of the private provision of an impure public good appears much more complicated, much more intricate than that of a pure public good, which is rather straightforward. And against this background, I will now tell you how the analysis of impure public goods can be, in also a very straightforward way, can be facilitated by reducing, transforming the impure public good in a specific pure public good one. So you learn in this talk, and I think you will be able to take some takeaway messages home after my talk. I will present a short review of the literature on private provision of public goods, both for the pure and the impure case, where the impure case is reduced in a certain way, traced back to the pure public good case. I will make use of the so-called aggregative game approach, but at the moment that is not so important. So, what I'm going to do in my talk. I said that the main topic of my presentation will be the transformation of the impure public good model and voluntary provision in this framework to a pure public good model. And I start in section 2 with describing the first step of this transformation that refers to the utility functions. Then, in the section 3, based on this transformation, I will describe how the non-cooperative outcome, you may know that, the Nash equilibrium as an oligopoly theory, can be determined, and how standard topic in microeconomics, how existence and uniqueness of this Nash equilibrium can be demonstrated. In section 4, which is very technical, on the one hand very technical, on the other hand very intuitive, I discuss the properties of the given impure public good utility function that makes this conversion into a pure public good utility function possible. Okay, and this was, okay, the transformation part of my lecture, of my presentation. And in the last two sections, I will describe what can be done, what insights can be provided with help of this transformation. So in section 5, we can, in a very easy way, because we have the same framework for them, discuss the similarities and the differences between the pure and the impure public good model. And finally, in the section, in the last main section, I will do some comparative statics. I will say later on what is meant by that. One parameter changes, and then we look at the change of the outcome of the Nash equilibrium. Okay, and in the very last section 7, I conclude and summarize my results. This is the agenda of my presentation. I start with the model. And I think this model is very easy to understand. We have n agents, and each agent has the utility function ui. That depends on 3, this is important, on 3 arguments. Ci is the private consumption of this agent. G is public good supply. Okay, and the benefits of public good supply are consumed, benefit all agents, that we will see later on. And this is the specific element of an impure public good. Zi is agent's I contribution to the public good. Here, technical assumptions, okay, and twice partially differentiable, but that's not so important. And okay, and here these are the derivatives, first the first derivatives, and then the second derivatives, and okay, we assume that they exist. Important now is that we assume that the first derivative of the third variable, the agent I, country I's contribution to the public good is positive. If we had a pure public good, it would be 0. But this means that, at least to some level, this will be described in detail in a moment, the contribution to the public good increases my utility because we have cleaner air or we have a better conscience for doing the right thing, the morally right thing. This is the important difference. Okay, derives private co-benefits. And now we do the conversion. This is very simple. I think this you should be able to understand from the start. For every level of the public good G, we define this function that only depends on agent I's contribution to the public good. And we substitute the contribution Zi by the difference between the initial endowment, Wi of this agent, and this contribution. That means the initial endowment is either used for private consumption Ci or for Zi, and this means Zi is equal to Wi minus Ci. And then we look at this maximization problem for each G. We maximize the utility, this utility of phi G that depends for a given G on Ci, and we have both cases. Either for some G, we get interior solution that is smaller than Wi, or, okay, we get a corner solution where the level of Ci that maximizes this function just is Wi. This is also technical. But what does it mean? Look at first of all at the case of an interior solution. You increase your Ci, you have additional utility from private consumption, but for a given G, this is important, you have a lower utility from your co-benefit. And you look where this just, the marginal utilities of these two effects just equalize. That is, in the first case, the Ci is that Ci hat is that level, depending on G, is that level of private consumption where the marginal utility of private consumptions becomes to get smaller than the marginal utility of the co-benefits. And the second case, this is also obvious then, is that when this doesn't stop, if you have no cessation of private consumption, even when you would increase your private consumption to the entire level of your initial endowment. This is the corner solution. And important is that the solution of these maximization problems, depending on G, are define cessation levels of the private consumption of an agent. In the first case, there is some cessation in between, and in the other case, there is no cessation. You will go to the entire level of, to the entire endowment level. Yeah, and what we are doing now, when you have understood this cessation, we will cut off the indifference curves for the given utility function, as an auxiliary utility function that is now a pure utility function, at this cessation level. You will see in a moment how this can be visualized in a diagram. And this means, left to the cessation point, given our assumption on the utility functions, the indifference curves are falling, and then, after repassing this cessation point, they become horizontal flat lines. And with that, we will work now in the future. So they have a kink at this cessation level. Okay. Yeah. And this is a cessation curve, and we assume, okay, that this is increasing. Okay. And then, when we are in the case 2, then the cessation curve intersects the line passing through the vertical line passing through the endowment point Wi 0. Okay, you will see this in a moment. And this is important for the rest. We have to make a distinction between two types. Okay, one type is there is some level of G where the cessation curve intersects this endowment line. And the other possibility is that is tangential to some level Ci hat that is either equal to Wi or smaller than Wi. You will see this in a moment, what this means. And in the second case, here we have, what do we define? We have here Gi hat is the level of the, in case 1, the level of the public good where this intersection of the cessation curve with the endowment line happens. And in the other case, case 2, where there's an approximation, then we set this GI hat equal to infinity. So in the subcases, either CI hat is equal to WI or it is small to WI. This you should keep in mind. We get, through this conversion, different types of agents. And this conversion is not possible these properties do not apply to the case of a pure public good. And this makes the model with impure public goods richer. Either the satiation curve cuts the endowment line or it does not. Becomes tangential to some line, to some vertical line. This you should keep in mind. So this was very simple to the conversion of utility curves. So, and I continue now. How can Nash equilibria now be determined? For that, for this analysis, I have to make some other assumptions. The assumptions how the public good G is provided based on the individual contributions of all agents. And here we assume that G simply is the sum of these individual contributions set I. So we have a summation technology with a marginal transformation equal to 1 for all agents. And this is, okay, the technical condition. Then we talk about non-cooperative Nash equilibria. And so we think about, first of all, when, under which conditions an agent will be in an equilibrium position. And so you remember your basic micro course, price-taking behavior, that's very analogous here. It will be in an equilibrium position when the marginal rate of substitution is equal to the marginal rate of transformation, which just now has assumed to be 1. So we look at positions where the marginal rate of substitution, the slope of the indifference curve, is equal to 1. And this curve, this is a technique that has often been applied for the case of pure public good. This condition, you know how the marginal rate of substitution can be derived from the marginal utilities, but that's not so important. We look at the curve at which the state MRS, marginal rate of substitution of agent I, is equal to MRT equal 1. And we make some technical assumptions on this, on the marginal rate of substitution, and then we get, this is technically a little complicated, how this expansion path evolves. And this is very similar. You might also remember your basic micro household theory to the income, to that what has been called income expansion path in the basic household theory. And now here, for the moment, here we're using technical, we get that this thing exists. Yeah, and then we can also, a little technical, see if an agent is of type 1. There's a drop-out point, some level of the public good, where an agent, if this is provided by the other agents, an agent loses interest in providing the public good. And then we say that the expansion path gets vertical. Okay. This is that what also has been observed in the standard case of a pure public good. Or the next case is that also as the satiation path, also the expansion path is asymptotic to a vertical line. Okay, this we have in mind. So here, in 3 figures, we see again the whole situation concerning the 3 types. Here, this is the same type as with the standard pure public good. Both the income expansion path and the satiation path cut the endowment line passing through Wi. And here we have asymptotic cases with the endowment line as an asymptote, or here case 2b, in which a vertical line that is closer to the ordinate is the asymptote of both paths. It's all very technical, and what we are doing, we then characterize, this is an important element, the basis of the understanding of the entire theory of voluntary public good provision. We have this condition. And what does this mean? This means every agent here, this is behind the summation, it has to be for the Nash equilibrium supply on her expansion path. That means nothing else than that he has to be in an equilibrium position, MRS equal to MRT, that's clear. And the entire condition means that the expenses, the total expenses for the public good, Gn in the equilibrium, plus all the sum of all private consumption levels has to be financed through the total initial endowment, that is the sum over all income levels WE. This is the core for the understanding. And as we have made this transformation of the impure public good to the pure public good model, and have, as in the pure public good model, considered these expansion paths, then we see that this technique can also be applied for the analysis of voluntary provision of the impure public good. Here, again, the explanation. Each agent is in an equilibrium position. What this is, analogous to basic micro, I have explained before. And equality of the left-hand and the right-hand side, the aggregate budget constraint has to be fulfilled. And we see directly there's no additional consideration or additional analysis required here, that existence and uniqueness of this Nash equilibrium with public good supply Gn is obtained in just the same way for impure and for pure public goods. And what is now important? Okay, look at Gn and look at this going back a little here, this standard case. If Gn is above this G hat, round hat, then this agent will be a non-contributor, a free rider, if you want. Just the same in this case as with pure public good. But you already see, considering the other graph, the other diagrams, what can happen here in the case of the impure public good. There is no such intersection, Gi round hat, and that means that in any situation, an agent of type 2 will make a positive contribution to the impure public good, and this makes a sharp difference to the case of a pure public good. Okay, that's it. Now the technical part. Here, the basic conditions we have for pure public goods to get quasi-concavity and binormality, that is normality for both public goods. That's not so important. You will get the slides. You can check this on the slides. What is important now? Making our transformation, we can calculate these second partial derivatives of the auxiliary function minor u by properties of the initially given impure public good impure public good utility function, major U. Calculation here, and these are the properties we have. This, when we have these properties, the transformation works, and analysis becomes, as I try to explain, very simple. What does this mean? The first three, decreasing marginal utility in all three variables, standard. More demanding is the explanation of the last three, the gross derivatives. And I have done this here, beginning here. U, so they are symmetric, okay, mathematics. U1, 2 means that there is complementarity between public good supply and the utility, marginal utility of private consumption. More public good supply increases, and this is very sensible, the utility we have from private consumption. Life is more agreeable when climate change is mitigated. And here, the next one, that's the gross derivative between 1 and 3. That means if I have higher private consumption, higher material well-being, okay, then also my co-benefits count more for me, sloppily speaking. And most problematic is the third condition. That's the gross derivative between 2 and 3. And here we have no complementarity relation, but one of substitutability. That means, and this I think could be discussed, yeah? And this may also change the impure public good model much when this assumption does not hold. That means that if more of the public good is provided, then what happens? My individual contribution, my co-benefits do not count so much any longer. And I have given here explanations. That means I'm only satisfied, I only have a warm glow of giving if I'm a moral pioneer, and if everyone else is also motivated by a warm glow of giving, I think, okay, it's not worth anymore. I'm only conforming, and this, I want to be outstanding in my moral actions. Yeah, and this could also hold from a technical viewpoint. If the others do enough for the public good, then my own climate catastrophe can be avoided, then my individual contribution is no longer worthwhile for me anymore. These are the explanations, but I think the third condition, I think there are good reason that the relation could be the other way around, and then, yeah, okay. And then we can also identify the types with given utility functions. That depends on the first derivatives. Okay. Yeah. And then we have considered special cases. The most important one is that where the impure public good utility function is additively separable. This is here under B. Okay. And then the gross derivatives all are vanishing, and the conditions I have stated just before reduce to the concavity of the partial utility function f, g, and h. This is that what you know, and there's another type, but this is not so important. So, this is the technique. And we also learn, that would be in an advanced micro course, something about properties of utility functions. Now, on these grounds, I can compare these impure public good model and the impure public good model. First one I told before, no special complicated technique is required for deriving, analyzing the impure public good model as compared to the pure public good model. And we also see, from our 3 diagrams, that also, this is a classical question in the theory of pure public goods, that it is very easy also in the case of impure public good to determine the contributors and the free riders. Because we know from the beginning that all agents of type 2 are contributors, so we only have to care about agents of type 1, and then the same technique. So Androni Maguire have designed something like this some years ago. There's the same technique as for pure public goods can be applied. Okay? And here, okay? Yeah, here, this is the criterion that also applies for pure public goods. Same algorithm can be applied. And what is important, and this is also empirically important, I also referred to that in the discussion before. When the co-benefits are strong, and thus agents or countries of a type 2, they will, as I said, always contribute to the public good, irrespective of how large the contributions made by the others is. And this has a consequence just for climate policy. And this consequence is that normally for pure public goods, one must be, there is a danger, or this is also even the regular case, that leading behavior, increased public good contributions by a coalition of the willing, will be responded by the outsiders of this coalition through reducing their contribution that may even go to zero. And this does not happen in the case of the impure public good. This negative crowding out effect is reduced, and the reason is, as shown in the model, that there are large co-benefits. And this, I think, is one of the empirically important messages of this talk. This, you will also find this on my slides, you will get later on. Okay, this is for the comparison. Comparative statics. I consider 2 situations. One situation, we only have to look at this equilibrium condition 2. If I have a parameter change that shifts an expansion path to the left or to the right, this will either increase or decrease the level of the public good in the Nash equilibrium. And then, if that happens for one agent, shift to the left will increase also the utilities of all other agents except the agent J, for which this shift happens. Okay, and here, empirical applications. This can happen, such a shift can be happen through changing the marginal rate of transformation, e.g. to subsidies, to matching. Dirk and I have written a lot on that, but that's a new message that also applies to the case of an impure public good. Or it can happen here through Kantian behavior. I gave on that lecture, I think, 2 years ago. And finally, simply to change of preferences for one agent, or through a change of productivity. Now, and this is in the literature of impure public goods, a very central topic. What happens through a change of the incomes, WI, WJ. In the case of a pure public good, you see, this will have no effect on the utility function, and thus will have no effect on the expansion power. But this is different in the case of a pure public good, impure public good, but as the derived pure public good function obviously depends on the income level. So, we think, what does happen if an agent increases, has an increased income? He would say, okay, we will have more interest in the public good. Clearly, richer agent, normality, more interest in the public good. But as it's shown in this part of my talk, this is not the case. Things are different. The interest in the public good of an agent in the impure public good model will be reduced when the income of this agent increases. And this might appear a little strange, but the reason is clear. If I have more income, then the difference between my original consumption level and the income increases. That is, my contribution increases to the public good, and having diminishing marginal utilities of my private co-benefits, okay, I will be confronted with decreased marginal co-benefits of my contribution, and my reaction would be to reduce my contribution to increase private consumption. This is here explained in detail, and this is particularly obvious in the case of additively separable utility functions. And we can then make a comparative static exercise. We can think about an income transfer from a country, a benevolent country, to another country, and the original country has no private co-benefits, transfers money to the country with private co-benefits, expecting that the donor country will do something good for the environment, for the supply level of the public good, but it will be disappointed because as the recipient country has private co-benefits, so that an increase of its income reduces its interest in the public good. In the Nash equilibrium, public good supply will fall. This is the second takeaway result I will present, and I hope that I have explained the reason for that in a way that you at least have an idea what the basic mechanisms are. You will later on get these slides. Okay, here, this is all. Only in specific cases we will have neutrality, specific assumptions for the impure public good preferences that are needed for that. Not only in special cases, you will have neutrality of transfers. That's a so-called Vaughan neutrality. That's one of the most important results of pure public goods. That means if I shift income, surprisingly, nothing will change concerning private consumption and public goods supply in the Nash equilibrium. And here, again, to summarize, okay, what we have, what's the difference between the impure public good model and the pure public good model? The impure public good model can be interpreted as a pure public good model, that's important, with cessation of private consumption as another feature. Then we can proceed with the same technique as for the pure public good model, also for the impure public good model. Okay, the old story again, nothing different. Old wine, new wine in old bottles, you might say. But then there are also differences. One difference is that you always have to expect that the impure public good models, countries are never free riders. Co-benefits may, under certain conditions, exclude free rider behavior. And the other main difference is that the differences after the transformation of the impure into the pure public good model, that the preferences are also depending on the initial endowment of an agent. And that also explains deviation from the war neutrality. Thank you for your attention. This is the end.
Yes, are there any questions?
You will get the slides, I think. And if you look at it, they should be to some degree self-explaining. And if you have questions, I think from a pure theoretical viewpoint, it's an interesting and stimulating theory, I must say, because I have done a lot of in these frameworks. So I'm a partisan in a certain way. And yeah, if you have questions, you can ask me that, and later on also via mail, and I will answer your questions.
Wolfgang, what came to my mind is what is not has not been here talked about too much is you have these co-effects, these private co-effects, which could frequently also be generated independently. So you have you have climate protection and you have local air pollution improvement as a co-benefit. But you also could use filters, for example. Yeah? So if you take the Korn-Sandler model, you have this alpha and beta, which can you of course change. But if you have an alternative technology, you also have an influence on the income restriction, because you also invest in filters or something like that. Yeah?
I think
wouldn't it? It came just to my mind. Wouldn't it also be possible to very smartly include this here? Because before we translate it into the pure case, this can be modeled, and then what you in fact do is only you add additional to the private characteristic of the impure public good, and also take a bit money away because you have to pay for it.
It is so you can have 3 impact factors, alpha, beta, gamma, for the 3 variables, and then I have calculated this. Then you get comparative statics for the Nash equilibrium when you are varying these 3 components. And the point is that, so I didn't present it here, that besides these 3 conditions on the gross partial derivatives, also other conditions concerning the elasticity of marginal utility of the 3 variables play a role here, so that things get a little more complicated here. But in the written version of the paper, this should be included in any case, because this, I think, I have not checked this in detail, might provide some new comparative statics results. Comparative statics, again, means you change one exogeneously given parameter, and then you look how the Nash equilibrium changes through this exogenous change.
Okay, yes, another question?
Hi there, thanks for the presentation. I'm interested in this warm glow of giving finding. and the idea that as more is done on the public good level, it becomes less, the co-benefits for the warm glow reduce. Have you seen any further evidence for that? It's quite an interesting finding in relation to the psychological impact.
You make, I think, in the case of warm glow, this could really be observed because the recipient country then has automatically, with its old original contribution in national equilibrium, a lower, as I said, a lower marginal utility. Concerning I have never thought about that. Technical given co-benefits, I do not see at the moment that this effect may happen.
Yes, there's another question.
Thank you very much, Professor Buchholz, for your presentation. I just have a short question. I heard also about the free rider problem from Professor Nordhaus, and he came up with the idea to set up a climate club. I just want to ask, are you also supporting his idea or conception?
Yeah, I think also for free riders, the income level that an agent has may play a role. That also in this model, if income of an agent is increased, he may, for interior solutions, lose some interest in the public good, but it even becomes less likely that in the national equilibrium he will become a free rider.
Thank you.
Thank you. Are there any further questions to this talk? I don't see any at the moment. Then thank you again.
Thank you again for listening to my talk.
And then we are now going to our lunch break, and we are going to meet here again at 2 p.m. Thank you.
Take it. I think your phone is better. Hocam, go this way. No, no, here. You can make it. You can. It's too close.
Without expanding it, it should be clear. Yes. It should be clear without you expanding it. I think it's better. Did you even turn it off? I think it's better.
You need to expand a little bit. You need to expand a little bit, and it will be okay, I think. Yeah. My soul is belong to heroism. You don't believe me? It's better? Okay, let's go to our
CO2 emissions. How important is for them market share? And currently we're working on a paper on this, and we try to test this to use observation and draw a conclusion from observation on weightings. That's, yeah.
Thank you.
Thank you. More questions? We've got some time left.
Okay.
But we don't have to.
Okay.
Okay. If not, then we've got a longer coffee break. So it's coffee break, I think, until 4:30. Yeah. And afterwards, there's the workshops, the group work again. So in case you're not participating in groups, we will see you at 6:30 in in the Ratskeller, where we had our lunch today too. And for all the others, see you at coffee break and then in the group work. Thank you. Okay, everybody, it's group work time. Please come to your groups. Thank you.
We have the health things. So we're talking about the
biological genetic ones. All right, guys. Thank you very much for today. Please come to an end soon because we have to close up the venue soon. So please end up the discussion. Make sure if you use the chairs from the tables, it would be greatly appreciated if you could put them back. And see you guys later in the evening for the dinner event.